Hello everyone and welcome to Simplicode's YouTube channel. I hope you guys are doing well. Today we'll be taking you through part 2 of this Python training program. But before we begin, I would like to take a quick confirmation from the viewers that if we are clearly audible and the screen is clearly visible. If yes, kindly type yes in the chat section, and if there are any changes required from our end, please do let us know in the chat section. Alright, I see a lot of positive responses in the chat section, so let's wait for some more minutes so that some more people can join us. Until then, let me tell you guys that we have regular updates on multiple programming videos. So if you are a programmer and if you want to learn something new, consider getting subscribed to our YouTube channel and press that bell icon to never miss any updates from Simplicode. Also, if you have any queries related to any topic we are covering in this particular video, please feel free to drop them down in the comment section only. We'll try to address your issues as soon as possible. I think we can get started now. Let's go through the agenda for today's video. We'll start this video with the object-oriented programming concepts of Python. Following that, we'll go through certain topics like inheritance in Python, polymorphism in Python, exceptions in Python, functions in Python, and packages in Python. All these topics we will cover are referred to as intermediate level topics. Moving ahead, we'll cover some more important topics like iterators in Python, generators in Python, then we'll go through some mini projects based on Python. Following that, we'll cover some advanced level Python topics like Python list comprehension, regular expressions in Python, serialization, partial functions in Python, Python closures, Python map, filter, and reduce functions. We'll finish this video by going through lambda functions in Python. As I've already mentioned that the topics we are going to cover in this video are intermediate level topics, so a little attention to detail from your end will be much appreciated, guys. I hope I have made myself clear with the plan, so without any further ado, let's get started with the first topic for the day. Over to our training expert.
Let's try to understand and get an introduction into what is object-oriented programming. Well, as the name suggests, object-oriented programming is all about creating objects. An object is a group of interrelated variables and functions. Variables can be referred to as the properties of the object, whereas the functions can be referred to as the behavior of an object. So if we were to treat, say, for example, a car as an object, its properties would be its color, its model, its price, and its brand. Whereas its behavior, or functions for that matter, would be like accelerating, gear change, braking. Similarly, if I gave you an example of a dog as an object, we could consider the properties of the dog as its weight, or its name, its breed, its color, whereas its functions could be, say, barking, playing, eating, walking, etc. Objects provide a better and a clear structure for a program. Now let's move on to what is a class and an instance. Now a class is like a blueprint or a template of certain functions and entities, whereas an instance is a particular realization of a class. Classes are used to create user-defined data structures and define certain functions called methods within the class, whereas instances are realizations of these classes. And when we are speaking of classes and instances, classes don't contain any real data. They are just merely templates. Instances, on the other hand, contain real data. To think of an example of the difference between a class and an instance, think of a class like a empty form or a questionnaire. Now, an empty form or a questionnaire does not have any information, but it does have a template to it. It tells you to fill in certain information, and based on who is filling in the information, that information or the data on a particular form will be different. So an instance is like a filled out form with its own unique set of information. That is one way of treating or understanding what is a class and an instance. Now for our first example on classes, I will be taking you through a class where I've defined based on the circle object. So this class is going to define basically information about your general circle, such as its radius and its area. So let's go through it. Now obviously, to define a class we need a keyword. Well, in the case of classes, we use the class keyword followed by a name for that class. So in this case, my name is circle. Now, after the colon, every information that is part of the class has to be obviously indented, as is typical for Python. Now you can see over here a bunch of def keywords followed by something that you might not be familiar with, and I will try to get you through this. So if you see here, you have a def keyword followed by init, and this init is prefixed by a double underscore and it's suffixed by a double underscore. And you can see the same thing for str and repr. Well, this double underscore is called a dunder, and any method, these are of course methods. This is a method, this is a method, this is a method, this is a method. Now any method that is prefixed and suffixed by double underscores are called dunder methods. These dunder methods are or can be thought of like predefined or built-in methods for any class that you define. So these we have like 3 dunder methods over here, and we have one user defined method that we will get to. So this first method that you see here is the init method or the initialization method, and this is invoked or called whenever we create an instance of this class circle. And what we do here is basically we pass when we create this instance circle, what happens is that we get an option to pass a value for what is this keyword or variable radius. So if I pass, so you will see me later on creating an instance where I will be passing a value, and that value is basically stored as the radius. And by default, the radius that will be passed whenever we create an instance for this class is 1. The str method is basically used to return a descriptive string for the instance of class. REPR is not something that you have to bother with right now. And now get area is something that you should follow, because if you see here, I have not used any double underscores. So this is a user defined method. User defined methods are so methods that we define, and these are like tasks that we define on our own. So in my user defined method called getArea, I will be returning the area of this circle based on the radius that I pass to it. Now if you notice here, before in every method, I have this self keyword before any other attribute. So like this has self, even the getArea has self. Now what this means, self is like an optional keyword that is used to improve readability of a program, first of all. And it's also the function of the self keyword is basically telling Python that any of the methods that we are invoking in this class or the instance of this class has to refer to attributes and variables within that instance of that class. So if I'm going to use getArea function, I'm going to get values and attribute values and variable values based on only the current instance of that particular class. Self is obviously optional, we don't really need it, but basically the first attribute of any method is basically what is the instance that the method is invoked upon. So if I say self, I'm telling this particular function that okay, all the value that you're going to get for performing whatever task you want is going to be found in that particular instance where you have been invoked itself. Now don't worry if all this is very confusing. This might be in the beginning, but just try to understand that this is something that we do for good practice, and you will understand when to use self or when not to use self as you learn about object-oriented programming. So if you see here, my getArea function is supposed to return the value radius times radius. Self.radius is basically telling whatever value I've passed for radius for that particular instance. You can read this as radius times pi as well. So obviously this is pi r squared, which is the area of a particular circle. Now let me show you an example where I'm going to perform some of these functions. So if you see this first line, I have created an instance of the class circle where I've passed 2.1 for the radius of the circle. So now the value of the variable radius in this particular instance is going to be stored as 2.1, and this particular instance is going to be stored in the variable c1. Now the print c1 function invokes the str self-defined or predefined function. Now if you remember, it's basically used to return a particular string that describes like what the class will do, and this is something that we define on our own. In our example, str will return the string saying this is a circle with radius of, and then it will return the radius that we passed. So in this case, it should say this is the circle of radius 2.1, as you can see over here. So if I execute this, you can notice this line. This is a circle with radius 2.1 and this is invoked by the print function. The print basically invokes the Dunder str function, which does all of this. Now in the next line we say print c1.getArea. So this is going to print the value of the what gets returned when we invoke the method getArea for this particular instance c1. So obviously in this particular instance our radius is 2.1. So the getArea function should do pi times 2.1 square. And the value is, as you can see here, is some 13.85. So that is the area that we got. Now if we want to print a particular radius, we just say print c1.radius. So this will print the value of what is stored in radius for the particular instance c1. Now you might notice me using a dot whenever it comes to defining a certain function or a keyword. Well, anytime that we want to invoke or use a method of a particular class, we have to use the dot keyword. So we use the instance name c1 dot followed by whatever method that we want to use. So if we want to use the getArea function, we say c1 dot getArea. If we want to find out what is there in the radius radius variable of a particular instance, we say c1 dot radius. Now before we move on, let's talk about some of the naming conventions. Class names are initial capitalized. So if our class name is, for example, if it's camel case, well, each word that is part of this class has its first letter capitalized. Variables and method names are in lower class. So if my class was called circle, we say class circle with C being in capital. Now moving on, let's talk about how we initialize or define instance variables. Now instance variables are declared within the init method. If you remember from the earlier example of circle, init is a Dunder method. It's followed and it's preceded by double underscore, as you can see here. Now if you see in this particular case, I have again used the self keyword, and as I mentioned earlier, the self keyword is the first parameter of all member methods. And this basically binds that particular method to the particular instance itself during invocation. So every time a new circle object is created, the .init function sets the initial state of the object by assigning the values of the object's properties. So the init function basically initializes each and every new instance of of our class. So we can give init any number of parameters, but the first parameter must always be a variable called self. Now when a new class instance is created, the instance is automatically passed to the self parameter in init so that new attributes can be defined on the object. Inside the init method, the self.radius basically means that we want the value of radius based on the current instance itself. So as you can see, radius defines an instance variable radius, and we're going to use the particular instance and its value for radius in our variable radius. Now the init function is not a constructor, but it is an initializer to create instance variables. The init function also will never return a value, and it is optional and can be omitted if there are no instance variables. Now let's move on to class variables. So now, as we mentioned earlier, all the attributes that are created inside the init function are instance-specific attributes. And the instance attributes are obviously specific to a particular instance of the class. For example, all dog objects. Now, if we have a class called dog, then all dog objects have a name and age, but the values for the name and age will vary depending on which dog we are talking about, or basically which instance of the dog are we talking about. Now, class attributes are attributes that have the same value for all class instances. And we define a class attribute by assigning a value to a variable outside of the init function. So if you look at this example over here, we have created another class called circle, and we have this initializer again, where we have a class specific variable called radius, whose value will change depending on whatever we pass for that particular instance. However, if you look before the init function or the initializer function, if you see here, we have another variable called shape object, which stores the string circle. And this variable is going to be the same and constant for every instance of the class circle. And unlike the variable radius, we will not have different values depending on a particular instance. Okay, now let's talk about instantiating an object, and let's see what happens when we create two different instances of the same class. So as you can see here, I've created an instance C1 for class circle, and I'm going to check its ID. Well, if you see, the ID is something like this. Now, if I created another instance over here called C2, and if I check its ID, Well, it's something different now. So if you see, each instance basically has a different memory location in our memory. And each instance this is how each instance is different each time we create it, and they are created in different memory locations. Finally, before we conclude this topic on the introduction into OOP, let's talk about class methods, instance methods, and static methods. Now, class methods are actually declared with the at class method operator or decorator, as you can see here. It accepts the class as its first argument. So in this case, I'm going to define a class called my class. I'm going to use this at class method decorator to say that whatever follows here is going to be a class method. And I've defined a class method called hello that takes in that uses again self and a name attribute. So what this does is it prints whatever I have passed to it in the form of hello from self.name. Now what this is going to do is basically it's going to give out a string saying hello from name of the whatever class we have and whatever we pass in the attribute name. So in this case, I'm going to invoke this method using the class name itself. I'm not going to use an instance name because I have no instance in this particular example. And since this is a class method, it can be invoked using the class name itself. So I'm going to pass Rakesh, and let's see what happens when we do this. As you can see, the first print will basically give us the information of the class itself. It's saying that the class is called my class, and the second print statement is basically a string saying hello from the string name my class with a comma and then whatever we passed initially, which was Rakesh. Next is then instance methods, and these are the most common types of methods. These are invoked by an instance object. So we have to create an instance to actually use an instance method, and it takes the instance or the keyword self as its first argument. So if I say if I define a class, my class in this example, and I'm going to define another function called hello. As you can see, I have not used any decorator like at class method. So this is going to be an instance method, and it's going to be invoked by the particular instance. So in this case, it's going to print hello from, and it's going to basically say the name of the class again. So I create my instance called my instance1, and it's an instance of this class. And then I'm going to invoke the instance method by using this dot operator and the instance name. And the result will be basically this string over here, as you can see. Now finally, we have another type of method called the static method, which is declared using the @static method decorator. So a static method does not know its class and is just attached to the class for convenience. It does not depend on the state of the object and could be from a separate function of a module. A static method can be invoked via a class object or an instance object. So if you look at this example over here, I have defined a static method. I've defined hello, and it basically says print hello world. So it's going to basically just print this. So if you can see here, I've created my instance and I'm going to say dot hello. It should basically print hello world. That's all. So guys, this was it for the introduction on OOP. We will continue that discussion on OOP with inheritance. Inheritance is used to describe the relationship between two classes, wherein one class takes the methods and properties from another class. In this relationship, we have something called the base class or the parent class, from which we will derive all or some of the properties and methods. And the class which actually derives these properties and methods is known as the derived class. So you can think of the derived class as a specialized version of a base class. To explain what inheritance is in a basic way, I will show you an example where I'm creating a cylinder class, which is going to be a subclass of the circle class that you might have encountered in the earlier video on OOP. So what we're going to do is create a cylinder class that is a subclass of circle, where we're going to get the attributes radius and get area from circle class, and we're going to add the attributes height and get volume to the cylinder. So right off the start, you can see we have our class circle that you might have seen in the earlier video. So this class circle has the familiar initialization where we are supposed to enter a value for a radius that gets stored in self.radius. Now we also have a description string, which basically is a Dunder method that returns a string when we invoke the print command on a particular instance. And we have the getArea method as well. Now if we move on to the cylinder class, you can see that I'm defining this class with the class keyword with the cylinder name, but you can see that I have added a parenthesis, and within it I have mentioned the name of the superclass that I want the cylinder class to be a subclass of. So this is how we actually define a subclass in the most basic way. You enter the name that you want, and you enter the name of the superclass that you want the subclass to be a subclass of in parentheses right after the name. Now next, if you move on to the Dunder initialization, the initialization is very familiar, except now we have another attribute for height, which has a default value of 1, just like the radius. So this basically means that we have an option of entering 2 different attributes for our cylinder instances. Now if you see here, there's a line which says super.init. Now this is like, this is a command which we use to invoke the superclass's initializer. So anytime we create an instance for cylinder, we also want an initialization for the circle method as well as a part of our cylinder instance. Next, you can see that much like how we stored the radius attribute in self.radius, we're also storing the height attribute in self.height. Now even this cylinder class has an str method to return a particular string if we use the print function, and finally we get on to a new method that we have defined only for the cylinder class called getVolume. Now if you see the getVolume, it returns us basically the volume of the cylinder that is being described in the particular instance, for which we enter the height and the radius. So if you can see here, what we basically added extra is a height attribute and another method called getVolume. And the other parts of the circle superclass, such as radius and getArea, are also going to be a part of cylinder, even though you do not explicitly see them anywhere here. And we will see how in the form of an example that's coming up. So let me just execute these classes. Now that that's done, I'm going to create an instance for cylinder. I'm going to store it in cy1, and I'm going to pass 1.1 for the radius and 2.2 for the height. And once that is done, let's just print to invoke the str method. And as you can see, the str method basically tells us the information that it's a cylinder with radius 1.1 and height 2.2. So now let's print what is the value we get when we use the getArea method. Now it's important to note getArea was not explicitly defined in the cylinder subclass, but it's a method that is a part of the circle superclass. And we can see that we can actually access methods that are part of the superclass simply by accessing any other method. So if we use the .getArea, you can see that we get a value for the area of the cylinder. So this area is basically the area of the circle face of the cylinder, the top or the bottom. Now let's invoke the subclass specific method, which is the getVolume method, in a similar manner. As you can see, just by invoking this method, we get the volume as well. Now, if we want to see what is the radius and the height, we can just do a simple print statement followed by cy1.radius, cy1.height, and it gives us both of these values, as you can see here. Now over here, what I'm going to do is create another instance of cylinder, but I'm not going to pass anything for radius or height. So basically, it's going to take the default values for radius and height, which was 1 and 1 respectively. So once I print, this statement is basically going to print the str method, or whatever we stored in the str, which is basically the description of the object followed by what is its radius and height. This method will give us the area, and this method will give us the volume. So once I execute this, as you can see here, this is what we get, and this is what we expect as well. So now in this example, what I'm going to show you is now I'm going to go back and I am going to create another instance for circle. Now this is the superclass, of course, and I'm going to give it, and since the superclass has only one option, one attribute that we can enter, which is for the radius, so I pass 3.3, and I'm going to print what happens when I just print this instance. It's going to basically give us whatever was a part of the str method. After that, I'm going to print is instance. This is basically a check on whether C1 is an instance of this class circle, and next I'm going to check if C1 is an instance of its subclass cylinder. Now when I execute this, you can see that this is what this is the str method that gets printed. But if you see here, you can see that it says C1 is indeed an instance of circle when it says true over here. But when we look at the next line, is C1 an instance of cylinder? It says false, and this is obviously because a superclass object is never an instance of a subclass object, whereas vice versa it would be true. Now in the next part of this video, what we're going to do is look at the different types of inheritances in Python. So there are basically 5 types of inheritance in Python. There is the single inheritance, there's multiple inheritance, multi-level inheritance, hierarchical, and hybrid inheritance. So we will go one by one and see each of these examples. Starting off, we have the single inheritance. This is simply where we have one base class and one derived class from that base class. So this is just simple single inheritance. And in this example, you can see I have a class called country where I have a method that I have defined called show country, which is basically going to say print this is India. It's basically going to go print this every time we invoke this show country method. Then we have a class called state, which derives from the superclass called country, where we have a method called show state, which is going to say print this is state every time. So you can see I created an instance of the class state, and through that instance I can access the superclass and the subclass methods over here. Next we have the multiple inheritance, and this is when a derived class contains more than one base class. So let's look at an example to understand this. So if you can see here, I have a class called student with two methods defined called method 1 and method 2. In method 1 we can pass two attributes, SN, SNO, or I think this is supposed to be like an ID, I guess, like SN number, and we have S name. So this is basically two attributes we can pass that are probably descriptors for a student. And in the next method you have basically two print statements which says student number, and then they will print the student number, and it will also print the student name. Next we have a class called marks. This is also so these two classes are basically what our super classes are going to be, and we're going to derive a third class from these two. So this second class is a class called marks, and we have two methods again. One method is called setMarks, which has the option of putting in two attributes, M1 and M2, both representative of the two marks, and we store them in self.mark1, self.mark2. The second method is putMarks, which is going to print the marks, namely mark 1, and then it's going to tell us how much marks are there in the first subject, for example, and another print statement doing the same thing for the second subject, or mark 2. Finally, we have a third class called result, which derives from two classes, marks and student. As you can see here in my parenthesis, I've passed in marks and student. Both are super classes, and our class result is going to derive from both of them. This is an example of multiple inheritance. And within this class result, I have two methods specific to this derived class called calc, wherein I'm going to basically calculate the total marks of the total marks, which is basically the addition of mark 1 plus mark 2, and then I'm going to have another method called put total, which is going to print me what is the total. So if you can see here, I have created an instance of this derived class called result, and I'm storing it in R. Then I'm going to access method 1, which is obviously a method from the first superclass called student, and I'm going to store, okay, so this is name is, I guess, Lucky, and he has 60 marks. Secondly, then I'm going to do our set marks, which is the method from the second superclass, which is going to set the marks respectively. So you have Lucky student, and his ID is 60, and he has got 50 and 60 marks respectively in, say, the first two subjects. And finally, I'm going to access the derived class method called calc. So this is going to do the sum. Finally, I'm going to also do our method 2, which is going to print our student number and his student name. Next, we're going to have put marks, which is going to tell us the what are the individual marks for mark 1 and mark 2, and then finally we're going to print the total marks with put total. So once I execute this, you can see here it says student number 60, student name Lucky, marks 1 is 50 as I written here, marks 2 is 60 as I passed here, and then total is 110, which is basically 50 plus 60. Our next type of inheritance is called multi-level inheritance. Now multi-level inheritance can be assumed as where you take a superclass, let's call it A, and you derive a class B from that class A. Now what if we derived a class C from B, and we kept doing this? So until, say, a class E. Now each of these steps is in its own an inheritance, but this whole relationship can be described as a multi-level inheritance. So let's take an example again. So this time I've defined a class called student, where I have defined two methods called setStud and putStud, or you can call it setStudent and putStudent. In my first method, I have two options of adding two attributes. Again, this is the student number, this is the student name. In my second method, I am going to print what is the student number and what is the student name. Finally, next we have another class called marks, which derives from the first class called student. This has two methods called setMarks, where I'm going to again get the option of adding two integers for m1 and m2, which is going to represent mark 1 and mark 2. And finally, I have put marks, the method which is going to print mark 1 and mark 2. Finally, I have another class called result, and this, if you see, this derives from marks. Now, if you see this relationship, you'll notice result derives from marks, whereas marks itself derives from student. And this is an example of multi-level hierarchy. And even as a part of this third class, we have its own methods called calc and put total. Calc will calculate the total as we had seen earlier, and put total will basically print that total. And we're going to do a very similar operation. We're going to create an instance of this third class result and store it in R. Then we're going to do basically, we're going to set the student details, his student number and his name. We're going to give him his marks 50 and 60. We're going to calculate what are the total. We're going to say, okay, now put the details of what is the student's number and name. We're going to also display his marks, mark 1 and mark 2, and finally we're going to display the total marks. So let's execute this, and if you see, it's basically the similar operation that we did earlier, but the only difference is, in the earlier example, our third class result was derived from marks and student together. So this was an example of multiple inheritance, whereas in this example, the result class derives from marks and marks itself derives from student. So this is an example of multi-level inheritance. Finally, we have, penultimately we have as our fourth example of inheritance called hierarchical inheritance. Pardon my mispronunciation, it's hierarchical inheritance. So in this case, a base class basically will contain more than one derived class. So let's look at an example of what we mean here. So I have a class called 1, where I have defined a method called display, where what I'm going to do is I'm going to store self.x is equal to 1000 and self.y is equal to 2000. Then what I'm going to do is I'm going to print a statement saying this is the method in class 1, and I'm going to say after that I'm going to print another statement saying value of x is self.x, which is going to be 1000. Then I'm going to have another print statement saying value of y is self.y, which is going to be 2000. Finally, next I have another class called 2. This is going to derive from class 1, as you can see here. And in this class 2, I have defined another method called add. And in this method add, what I'm going to do is I'm going to first print a statement saying this is the method in class 2. And then I'm going to actually print the result of x plus y, which is 1000 plus 2000. Finally, I have another class called 3. And this is also deriving from 1. So if you notice, we have one parent class called 1. And from this one parent class, we're going to derive two different subclasses called 2 and 3. So this is an example of hierarchical inheritance. Now in this class 3, what I've done is I've defined a multiplication method. What I'm going to do is print, first of all, I'm going to print this when I invoke this method, that this is the method in class 3. Finally, I'm going to say, I'm going to print the result of x times y, which is 1000 times 2000. So if you see, I am going to create an instance of 2 and I'm going to create an instance of 3, and I'm going to store them in T1 and T2. Now since T1 is an instance of 2, so I can access its methods add and I can access its methods display. So I'm going to use T1.display, and even in T2, since it's a class, it's an instance of class 3 and this also derives from class 1, I can also access its method display, but now I cannot access add, but I can access multiply. So if you see here, I access add through T1 instance, since add is a part of class 2, whereas multiply is a method in class 3, so I access it in its respective instance, which is T2. So if you see here, now once I execute this, what you will get is basically the results. So first of all, it will basically display the method from class 1, which is a display method. It will display the values of x and y. And since I've done this twice from two different instances, it will basically show a repetition over here. Finally, I've done the addition, and since this is a method in class 2, it is going to say as much, that this is a method in class 2, and then it's going to say x plus y is 3000. And now multiply is a method in the third class, so it's going to say this is a method in class 3, and it's going to tell me what is the multiplication result. Finally, we have what is called hybrid inheritance, and this is a combination of multiple plus multi-level inheritance that you saw earlier. So let's again understand this through this example. So we have a class called student, where we have a method called setStudent. Again, two attributes we can pass here for student number and student name. Next, we have another method, part of the class student, called putStudent. So this will print us the student number and student name. Next, we have a class called marks, and this marks inherits from student. So we have a method in class marks called set marks, where we can pass two attributes for mark 1 and mark 2 respectively. And as we had seen earlier, we also have a put marks, which will display the marks for marks 1 and marks 2. We have a class called practical. This practical is basically another superclass. If you see here, since this does not derive from anything, it is a superclass on its own. What it does is it has two methods, get practical, and we can pass an attribute for p1 here, and we store that in self.p1. And then we have an attribute for put practical, which will print us the practical marks, whatever we passed for this attribute in p1. Finally, if you see, we have a class called result. Now in this result, we are going to derive from marks and practical. But if you notice here, marks itself is a subclass of student. So this is an example of multi-level inheritance. Whereas since result derives from marks and practical both, it is also an example of multiple inheritance. So if you see, notice here, this is an example of multiple and multiple level inheritance, which is basically what we call hybrid inheritance. And as we had seen earlier, this result class will have a calc method to do a total of the marks. In this case, mark 1 plus mark 2 plus the practical mark p1. And we have a put total method, which is basically going to print us the total. So now we're going to create an instance of this result. And through this instance of result, we're going to first invoke the parent class method called setStudent, which is the second level parent, basically the student class setStudent method. So we're going to set student here. We're going to say 60 is the student ID and name is Ash. Then we have set marks, which is again the second level parent, which is a student class, where we set the marks. Finally, we access this get practical. Now, if you notice, get practical is part of the practical superclass. So in this, we store the third subject, or the practical marks 100. Then we calculate the total, and we put first the student details, then we put the individual marks, then we put the practical marks, and finally we enter what is the total. So let's execute this. And if you notice, you will see here student number is 60, student name, and all the basically whatever details we wanted is shown over here. Now we'll continue our discussion on object-oriented programming with the topic of polymorphism. Now the term polymorphism in OOP refers to the ability of an object to adapt the code to the type of data it is processing. Polymorphism is one of the key concepts of Python, and it is also a built-in feature of Python. An example to get us started on polymorphism would be how we use the plus operator. We use the plus operator not only for arithmetic additions, but we also use the plus operator for stuff like string concatenations or joining two lists together. This example where we're able to use the plus operator for different operations is an example of polymorphism. To show you what I mean, I have basically done a simple addition operation here, where I'm adding two variables, number 1 and number 2. When I do it on integers, it basically adds 1 plus 2. Now when I use it on two strings, str1 and str2, which contains Python and programming, two separate strings, and when I use the plus operator on these, you can see what it does here. It forms one string containing both of these individual strings. So this is basically the plus operator showing polymorphism, and is one of the simplest occurrences and yet most common occurrences of polymorphism in Python. Another example of polymorphism would be through the length function. The length function in Python is something that we use a lot and over multiple data types. Depending on the data type that we use the length function for, we get a different value or a different sort of information from the length function. Now if you see here from this diagram, when we use the length function on a string, it gives us the length of the string. When we use the length function on a list, it gives us the number of items. Whereas if we use the length function on a dictionary, it gives us the number of keys. So this is, well, another example of how we have polymorphism in a function. Now what we're going to do is look at the different techniques through which we can enable polymorphisms in our code. Our first example that we are going to look at is through method overloading. Now method overloading in its traditional sense, where we can have a method with the same name, more than one method with the same name in the same class, is not exactly possible in Python. So if we have multiple methods with the same name in a class in Python, which may differ in types and number of arguments, are not allowed and not supported in Python. In fact, if we did something like this, where we created a method with different say types and number and arguments, but having the same name in the same class, then what Python will do is it will only recognize the last defined method, and it will not recognize any of the earlier methods with the same name. But we can simulate polymorphism through method overloading by using default arguments in a method. Now, for example, what I'm going to show you here is an example where I have a method called sum. Now, by default, it has three attributes that you can pass through this method. A does not have a default value, B does not have a default value, but if you notice, C has a default value 0. So this is a simple example where I'm going to show you that the sum method is going to be used in two different cases. In one case, we're going to simply add two numbers, and in another case, we're going to use the sum method to add three different numbers. So we have this class overload demo, within it a method sum, and I have three attributes. A and B are supposed to be given by the user since they do not have any default values, whereas C has a default value 0. So if you see here in my first case, I first of all created an instance called OD for the class overload demo, and what I'm going to do is I'm going to store the value of the sum of 7 and 8 in the variable sum. Now, if you see here, I have not passed a third argument. So what this method is going to do is it's going to take the value of C as 0 by default. So it's basically going to do 7 plus 8, and it's going to give us the sum for 7 plus 8. And in the next instance, I'm going to give three arguments, 7, 8, and 9. So now C will be replaced by 9 instead of 0, and then I'm going to get the sum of 7, 8, and 9. So in this is not a very commonly used thing, but it's basically a method just to show you that we can actually simulate method overloading in Python by using default arguments. So I've basically shown you how the same method sum has been used to do the addition of 2 digits, and then in another instance is doing the addition of 3 digits. It might look very similar, but you'll basically notice that by having this third attribute C, I have a default value of 0. I have induced some form of polymorphism through method overloading. Now, the next way that we can induce polymorphism is through inheritance, which is called method overriding as well. Now, method overriding gives us the ability to change the way or change the implementation of a method in a child class which is defined already in one of its superclasses. Now, if there is a method in a superclass, the method having the same name and same number of arguments in a child class, then the child class method is going to override the method in the parent class. So what we do is when a method is called with the parent class object, the method of the parent class will be executed. Whereas if we call the method using the child class object, the method of the child class will be executed and it will override the method in the parent class. So the appropriate overridden method is called based on the object type, which is an example of polymorphism. So let's look at an example to understand this. So we have a class called person, and we have defined what we're going to define the initializer is 2 attributes which we have to pass called name and age, and we're going to store them in self.name and self.age. Now we have a user defined method called display data, where we're going to print if this display data has been called through the parent called person. If it's going to be called through the parent class object, then we're going to print in parent class display method, and then we're going to print the name and age that we have entered. Now we have another class called employee, which is going to be a derived class on person. So it's going to so it's also going to have an initializer, and this constructor will basically what this initializer will have is it'll have an constructor for the superclass, where we're going to do this the same initialization that we do in the superclass, but we're also going to store another attribute called ID in self.employeeID. And if you see here, we also have another method called display data, which is the same named method from person. But now if you see in display data, I have almost the same information. I'm going to print the name, I'm going to print the age. But if you see the first statement, I'm going to say, if I'm going to call this method from the employee object, then I'm going to say in child class display data method instead of in parent class display data method, to say that basically I'm invoking this method from the child class object. And I'm also going to print on top of the whatever I'm printing before, I'm also going to print the employee ID. So if you see here, I have created an object called person, which is an object of the class person with the information of name John and age 40. And then I'm going to display this. Now next I'm going to create an object called emp, which is the child class employee object, which is going to now have the same information of John for the name and age 40, but now it's going to have an employee ID. And then I'm going to store this in emp, and I'm going to display the data for this child class object, and we will see the difference in how the display data is differing from the earlier case. So when I execute this, you see in the first case it says in parent class display data method. So this display data has been called through the parent class object, and I'm only going to show the information of name and age. Whereas when I invoke this method from the employee class object, it's going to say it's going to specifically say that it's a in child class display method, and then I'm going to say the name, age, and also the employee ID over here. So this is the difference between how display data has been used in its parent and its child class, and this is basically the example of method overriding. Now our next example of polymorphism is going to be through operator overloading. And operator overloading is the ability to overload the operator to provide extra functionality in addition to its real or core operation. And operator overloading is also an example of polymorphism, as the same operator can perform different actions. The earlier example of where we use the plus operator for different operations is an example of operator overloading polymorphism. Now when is operator overloading required? Well, anytime you want an operator to perform a different function for you in your custom objects, you would basically do operator overloading. Now an example of this would be what I'm going to show you below. So if you see this class called point, it has an initializer where I'm going to store two attributes x and y in self.x and y, and in self.x and self.y. Now I'm going to create one object called p1 where I'm going to create point 1 and 2. So you can think of this object as basically like a coordinate, x coordinate 1, y coordinate 2. This is one point, and another point called x coordinate 3, x coordinate 4. I'm going to call that p2. Now I want to print p1 plus p2. Alright. Now if I try to execute this, you will notice an error. It says unsupported operand types for plus, point and point. This basically means that plus does not know what to do when it's given an object of this type. It has no idea what to do. Whereas what we want it to do is add the x coordinate from this point and the x coordinate from this point. So we want it to do 1 plus 3, and we also wanted to do this y coordinate plus this y coordinate, or 2 plus 4. And then we want to print basically like something like 4, 6, or the addition of the 2 points, or the vector addition of these 2 points. So this is what we want this plus operator to do, but the Python does not have any inbuilt feature for the plus operator, and we are going to have to basically do some operator overloading to create a polymorphism on this. So let's see how we can do that. So to do that, first of all, we have to understand that all operators in Python have internally defined methods to provide functionality for these operators. The operator, or the special method to provide functionality for the plus operator in Python, is the add method. And whenever the plus operator is used, we are basically internally invoking the add method. So these sort of internal methods that provide functionality for the operators are part of a bigger class of methods known as magic methods. And these magic methods are automatically invoked whenever its corresponding operators are used. So if we want to change the operation for the plus operator in this example, we are going to have to use the add method in this case. And since it's a magic method, magic methods are also are basically what we saw earlier in the form of Dunder methods. So magic methods are going to be invoked using double underscore, a prefix and suffix to it. So similarly to how we defined an init method or an str method, we are going to also invoke the add method using the same double underscore before and after its name. So now let's see how we're going to do this. So if you see this class, I have now my class point, and I have the same initializer when I'm going to store x and y. Now I am going to define on this add magic method, I am going to override the normal functionality of plus, and I'm going to give it a very specific function where I'm going to say for two different objects, you're going to add its the first part or its so-called x coordinate with the other x coordinate, and the y coordinate with the other y coordinate, and you need to return this to me in the form of a similar object. So now when I pass 1 and 2 and 3 and 4, it should return me 4 and 6. As you can see here, I have basically done what I wanted to do by operator overloading. I have changed, or I have overloaded this plus operator using this add magic method, and I have created a new functionality for this add function for these 2 points 1 and 2, 3 and 4. Now I'm able to add 1, 2, 3, 4 in the way I wanted to. So now that you saw how we did operator overloading, I'm just going to show you a list of similar magic methods for different operators that we are familiar with. So the plus operator already we've seen has the add method. Then we have the minus operator with the sub method, and similarly we have for all of these operations such as multiplication, division, we have its respective magic methods. These magic methods are again prefixed with 2 underscores and suffixed with 2 underscores, and they are also called dunders in Python. So this is how we would do operator overloading in Python for whatever operator we want. Similarly, we can do this for like comparison operators and for unary operators as well. So look at this example now where I'm going to overload the multiplication or the asterisk operator. So I've again defined a class called point. I'm going to define an initializer where I'm going to store some attribute x in self.x. Now what I'm going to do is I'm going to overload the multiplication operator where I'm going to basically allow the this asterisk operator to multiply two objects from, like, for example 12 and 5. Usually I can just do a normal 12 times 5, but in this case my object is slightly different. My 12 is being passed through an object of a class called point, and 5 as well in another instance of the same class. Now when I want to multiply these class instances, like the multiplication operator does not perceive these class instances to be integers. So by default it would not be able to multiply what we want to multiply. But when we define or we overload the multiplication operator within our class, it's now able to understand what to do using the attributes of these classes in its respective class instances. So it's able to say, okay, so I want this attribute from this particular instance P1, 12, and I'm going to multiply it with the attribute 5 from instance P2 whenever I say P1 times P2 or P1 asterisk P2. So when I execute it, it will give me 12 times 5. Similarly, I can also do this for the greater than operator over here. So I have a class called person where I'm going to define an initializer where I'm going to pass name and salary and store them in self.name, self.salary. The GT method is basically the greater than method, magic method, and it's going to we're going to use this to overload the greater than operator. And now again, using this greater than operator, I'm able to basically say object 1 greater than object 2, and I'm basically able to check through this, and if object 1 is greater than object 2, it will basically tell us if it is true or false, or basically whatever like we want to know. So basically the print statement will check for object 1.name, and it will say earns more than object 2.name if in case object 1 is indeed greater than object 2. So when I execute this, you can see here my first information says John is earning 4,500 of some units, Natasha is earning 6,000 of some units. So it will say John earns more than Natasha. Well, it's false because object 1 is not greater than object 2. So since 4,500 is not actually greater than 6,000. And this is the check that I'm doing by overloading the GT operator over here, where I'm returning the Boolean value of what is greater, self.salary or other.salary. Self being the first object in any comparison. So if I'm basically any comparison, if I'm doing 5 greater than 6. So what the GT will do is this will be the self object and this will be the other object. So this is what I'm doing over here. I'm checking self.salary with other.salary in the form of these objects. And it's basically the same way that we are able to do 5 plus 5 through these class instance objects that you saw earlier, or 12 times 5 that you saw earlier. So this is all examples of operator overloading in Python. Now we will be learning about exceptions. Exceptions are errors that are raised during the execution of a program. When an error occurs, Python generates this exception that can be handled, which avoids our program from crashing. Python has many built-in exceptions. However, we can create many user-defined errors or exceptions as well to catch whatever errors we're looking for in our program. So when an error occurs, Python interpreter raises an exception and stops the current process. And it passes it to a calling process until the exception is handled. And if this is not handled, the program will crash. Some of the built-in exceptions are like IO error, in the case when a file cannot be opened, or import error, Python cannot find the particular module being imported. And there are so many similar, exceptions that are built in Python for the appropriate cases. Now, before we move on and see how we raise these exceptions, let's look at the difference between an exception and a syntax error. So for that, I will be using an example where I will be dividing something by the number 0. Now, of course, this is not possible. So let's see how Python handles this particular problem. Well, it raises what we call a zero division error. And this is an exception that is built in Python whenever we try to divide something by 0. Now let's look at the difference between this exception and a syntax error. So this is the same statement, except I'm going to add this extra bracket, which does not make sense syntactically in this. Now if I try to execute this, as you can see, we get a different type of error known as the syntax error. And it says the unmatched closing bracket. So this is what a syntax error looks like an extra bracket or a comma that basically makes the line unreadable to the interpreter in the first place. So the interpreter doesn't even get to the point where it needs to figure out that there's something being divided by 0. It doesn't even get to that point because it finds this extra bracket and it cannot execute this line at all. So that is like the difference between an exception and a syntax error. Alright, now for our first case of how we raise or how we handle exceptions, let's look at the keyword raise. So for this example, what I will be doing is I'm going to take this variable x, alright, and I'm going to store a value 10. And what I'm going to do is I'm going to check for a condition. If x is greater than 5, then I'm going to raise this exception using the raise keyword like this. And in case this condition is met, if x is actually greater than 5, I want this particular message to play out in my exception. So let's see what happens when I execute this. As you can see, the exception is raised because x is indeed greater than 5, its value is 10, and the error message says as so that x should not exceed 5, the value of x was 10. So this is an example of how we can raise an exception. And as you can see, when a condition was met, the program comes to a halt and an exception was raised. Now let's look at another type of handling exception where we use the assert statement. So when we use the raise command, we waited until an error occurred and our program crashed midway, right? What if we want to check if a condition is met? And if this condition is met, then the program can continue. But if the condition turns out to be false, then we want a particular error, namely the assertion error exception, to be thrown to us. So we can use the assert command in such a case. So in our example, we will be checking whether the system that we are working on is actually Linux or Windows 32. So let's see. First of all, let's import a library called sys. This is it's a library where we can access system information. One of the modules in that is one of the functions in that is the platform. It basically tells us what system are we working on. So we're working on a Win32 system. Okay. So let's use the assert keyword. All right. Now we're going to check if Linux is what we are working on, and in case it is not, then we want an error message, and this will be the error will obviously be an assertion error because we are using the assert keyword. So this is how we use the assert statement. And if we execute this, as you can see, we get the assertion error because sys.platform contains Win32 and not Linux. And so we got this assertion error. So if we change this to check for Windows system, we won't have any error when we execute this, as you can see. So this is the example where we use the assert statement. Another way of handling exceptions is by using the try and except block. So this is probably one of the most common ways of handling exceptions in Python, where we use a try keyword and an except keyword. Now within the try keyword, as you can see here, we have a chunk of code which we're going to check. And if everything is fine in the try keyword, then this is perfect. So we don't need to move on to what we call the except part of the try and except block. But if say there was an error in the try block, then we move on to the except block where we're going to run the part of the code in the case we find an error in the try block. So first we check the part of the code that is under the try block, and if there is an error, we move on to the except block and we run that part of the code over there. And in the except block, that is where we handle our whatever error that might get thrown our way in the try block. Okay, let's look at an example at how to use this technique. So I have a basic function out here. All right, it's defining a function called Linux interaction. What this is basically doing is that when I call this function, I want to do an assert check. I'm going to check if Linux is the system I'm working on, and if it is not, then I want this error to be thrown. Okay, and so yeah, let's see what happens in the case. And if this assert statement is actually passed, then we will move on to this statement. So you look at it like this: if when I call this function, it will first check for this assert statement. In case something wrong happens and we get an assert error, then we do not move on to this line. So we only get this printed. But if this assert statement passes, then we move on to this line and we get print doing something. Okay, so let's see. Now I'm going to call this function out here. Let's see what happens here. As you can see, I get an assertion error because obviously this is a Windows system and not a Linux system, and I get this message. Okay, now let's see what happens when we use it in a try and except block. Alright, so now I have a try block over here in which I am going to try this function, Linux_interaction. If in case I find an error, I immediately jump from the try block into the except block. Now you see the slight difference in how we handle this. Like what happens. So as you can see, when we use the function explicitly, we directly went to what we call an assertion error. But when we use a try and except block, we will not use the assertion error because we are leaving the try block immediately and we're going to go into the except block where the only thing we're doing is printing the statement. As you can see, we are not on Linux, found some error. Okay. Now what if we wanted to catch the error within this function itself, which was the assertion error, and we can do that explicitly like this. So now what I'm doing is I'm going to try, alright, and it's going to catch an error in this, right? So now in the except block, I'm going to say the assertion error that we found in this function in the try block, we're going to use that in our except block. So as you can see, we're going to print that assertion error. It will basically print this statement. Function can only run on Linux systems. As you can see here, function can only run on Linux systems. Function can only run on Linux systems. And the next part of the thing was the Linux interaction function was not executed. Okay, so this is something very important happening here. When we use this assert statement, the whole program is actually getting executed, right? But when we're using the try and except block, we are immediately jumping on, like the moment we catch an error, we are immediately jumping onto the except statement. And all the handling of the exception is done in the except block and not in the try block anymore. So we have to think of it like this, that the try block is only to check if a particular piece of code is does it have any errors or not, and in case it does, then all the handling that we do is in the except block of this particular statement. Now let's look at another example. In this example, I'm going to try opening a particular file. Now this file does not exist, so I will get a file not found error, and this is a built-in exception. And I'm going to catch that and I'm going to print that error over here in the except block. Alright, so as you can see, file not found, and whatever error I have, I printed over here. Alright, so this is another a file not found error that we caught in our try block, and we're handling it in the except block. Now let's combine both of the examples where we use this Linux interaction and we also try to open a particular file, and we try to do both things in the try block. And since both of these contain errors, let's see what happens when we have multiple errors in a try block. So as you can see, in my try block, I'm not only doing this Linux interaction, I'm also trying to open a particular file that does not exist, obviously. So now you might think, will I get two exceptions? Well, let's see what happens when we try to execute this. So it's important to note that in our except, we have an except for catching a file not found error, and we also have an except for finding the assertion error that is part of this Linux interaction function. So since both of these are erroneous statements, they will throw exceptions. So now the question is, will we get both of these except blocks, or will we get both of these exceptions? Will we get only one of them? Will we get the first one? So let's see what happens. So as you can see, my error statement is very much like the assertion error that we had done as part of this Linux_interaction function. Function can only run on Linux systems. The Linux function will not execute it. So as you can see, that is the one that has been caught, and for some reason the file not found error has not been caught. And this is because this is a very important feature of the try block. The moment we find the first error in our try block, we immediately leave and we do not execute any of the further statements, and we jump into the exceptions and we handle it using the except blocks. So the moment an error was found in this function, we did not execute this part of the statement and we directly jumped into the respective exception. That was the assertion error exception. So this is a key takeaway. So some of the other key takeaways when it comes to exceptions is a try clause is executed up until the point where the first exception is encountered. And in the except clause or the exception handler, we determine how the program responds to this exception. We can have multiple exceptions and we can differentiate how the program responds to each of these. And it's also very important to not use except clause on its own. It's very important not use a bare except clause. Now finally, before we conclude this topic of exceptions, let's look at the else and the finally clause. So the else clause is used when we want to execute a particular piece of code in the case where we have no exceptions or no errors found. So let's look at this. Just like we had the Linux interaction function, I'm going to define a win underscore interaction. And this is going to check whether our system is Windows or not. In case it is not, then we get this error message. Alright. And in case it is a Windows system, we print this in the case of when we call this function. So let's again use our try and except statement. Only in this case, we will be using an extra else clause. So we first try this function. In case there's an error, we catch it as an assertion error and we print that error. But if there is no exception, then we move on to the else statement and we print this. So as you can see, we have actually moved on to the else statement and we print this line executing the else clause. And that is because we have found no exceptions over here. So again, it's key to remember that the else clause is used whenever we want to execute a particular statement in the case where we do not find any exceptions in the try block. The finally clause is used when we want to execute something regardless of whether we have an error or an exception or not. So no matter if an exception happens, is raised, or if it's not raised, we want this finally block to always get executed. And let's look at let's look at an example of it being used. So I have this block where I'm doing a lot of things. The first thing that I'm doing is I'm going to check for this Linux interaction function, which is going to check, of course, whether it's a Linux system or not. This is I'm doing the try block. Now, if I catch an error, that I want to handle it by simply printing the error over here. And in the event that there is no error, then I will move on to the else statement and I will try this particular block of my statement, which is again that where I'm trying to read a particular file that does not exist. And it's very important that you note that within the else block, I have another try and except block, and this is perfectly legal and it's perfectly valid in our program. We can do this. So think of it like this. I'm first trying this. If I have an error, then I do this and I don't execute this. But if I don't have an error, then I execute this whole statement, which contains its own try and except block. Alright. But regardless of whether I get an error here or not, I will always execute this portion of my statement or under the finally clause. So let's execute this. As you can see, of course, the error is raised in this try block. So we move on to the exception, and that is what is printed over here. And after the exception is done, we move on to the finally. We of course skip this else block because the exception was actually raised. So after that is done, we move on to the finally block where we print this particular statement. Now we will be taking a brief introduction into what is a function. So a function in Python is a group of related statements that performs a specific task or tasks. Now functions help break our program into smaller and modular pieces of code, and it's very good and very convenient to use functions to make our code organized and manageable, especially as our overall program grows larger. It also helps us to avoid repetition and makes the code reusable. So let's look at the basic way of defining a function. So this is a basic function that I'm calling fun_name. Alright. Now the rest of the function, or whatever the task is going to be performed by this function, will be written over here with an indent, of course, as a standard when it comes to Python. So I'm going to define this one something in double quotes. So don't worry about what this is right now. This is a doc string. Don't worry about what this means, and I'll explain it to you just in a short bit. Alright. Now the rest of the statement, the rest of it will obviously be what this function will do. Let's include a simple print statement. Alright. Let's done here. And let's call this. So of course, once you define the statement function, to call the function, you just have to use its name like this. This is how you call a function. So as you can see, when I call this function, it should print the statement hello. Now let's look at some of the like what happened over here. So we've used the keyword def to define a function. We give it a unique name, which makes it with which we uniquely identify this function. And also, once we've done this, we can give this function a particular header. It's called a doc string. So what this docstring is basically something that we include in triple quotes over here, just after the def keyword. And this is like a brief, we can use this to give a brief, give brief information into what our function is doing. So we can say this is, this function performs addition, this performs subtraction or whatever, like some basic information as to what our function does. So we can use a docstring for that. Of course, this is an optional thing. This does not have to be, we don't have to include this as well. Alright, but for the sake of this, let's just keep it here. After that, of course, rest of the function will contain whatever task we want to do with it, and that will be indented. Finally, we can also include a return keyword. And what the return keyword does is, at any point you find the return keyword in a function, you immediately leave the function and you go back to where this function was called. Okay, so now let's see. Now there's also one more important component of defining a function, and that's parameter. Now if you noticed over here, within these parentheses, I did not include anything. This is like an empty parenthesis, opening and closing. What if I said a, if I included some a and b over here? So what this means is, whenever I call this function, I need to pass two parameters, a and b. These can be like strings or numbers or whatever. But now it becomes almost mandatory that I pass these two things for my function to work. So let's define a function where I'm going to add a and b. So instead of this print statement, let's do this. I create a variable c, and in that I'm storing a plus b. Alright, and then I return c. So you can use a return, and you can return certain like variables along with the return statement. So I'm saying not only return from this function, but also give an output or return an output called c, which is the addition of a and b. Now how do we use this? Well, now instead of just calling the function like this, I'm going to include parameters. So I'm saying pass 2 and 3 to function name, where 2 will take the place of a and 3 will take the place of b. Alright, what will happen now is addition will take place and we will get returned the result. So let's see what happens now. As you can see, 2 plus 3, and I got the addition of 2 plus 3, and it returned me 5. So yeah, this was like a basic usage of a function and parameters. So of course, we can, if you want to know like what the docstring of a particular function does or says, you can use this statement. So let's say it's very important to like just keep a note in your while you're going through this or while you're learning that whenever we use some sort of a function which has double underscore, right? This is like a built-in command provided by Python within the Python library itself. So these are like built-in commands to check certain details. So I want to check what is the docstring, and this is how I do it. So let's do print. Let's print what is the docstring over here. This is a docstring. So this is basically what I wrote over here. I can change this to this, like this does addition, for example. All right. Now this will say this does addition when I execute this line. So this is the way to check what is a docstring. Anyways, so now that you have seen a basic function or two basic functions that I defined for you and how we use them, what a parameter is, let's look at another concept that we call scope and lifetime of variables. So scope of a variable is the portion of the program where the variable is recognized. All right. Now a parameter and a variable that are defined inside a function are not visible from outside the function. This is a very key thing. So if we define something within the function, we can only use it within this function, and we cannot use it once the function has already been executed, so as to speak. These variables and these parameters have what we call as local scope, since they are only recognized within a particular function. Now the lifetime of a variable is the period throughout which the variable exists in the memory itself. And it's very important to note that lifetime of variables that are defined inside a function are as long as the function executes. Once we return from a function, whatever we have defined within it are destroyed. So when we use a function, it will not remember the values of a variable from a previous iteration of a function call. So let's try to understand this example or this concept using certain examples. So out here I have defined a function where I'm going to create a variable my underscore var, my variable, and I am going to store the value 10 in this, and then I'm going to print. So whenever I call this function, I will always create this variable, I will store 10, and I will print the value of this. Alright. Now, what I'm going to do is, I'm not only going to create this myVar inside this function, I'm also going to create a variable outside. So you see there, now you might be confused as to, okay, how is the behavior going to be? Because outside the function, I have created myVar with a value 20, but inside the function, I will always define myVar as 10. Okay. Now I'm going to print. So what I'm going to first do is, I'm going to execute this function that I created initially, where I store the value of 10 in myVar, and then I'm going to print the value of myVar that was present outside the function. Let's see what happens. You can see two different things happening. So when I execute this function, it prints the value inside the function as 10. But when I print the next line, which says, okay, now get the value of myVar, it actually prints a value of 20. And this is a very key concept, because what's happening here is when I initially call my function, within this function, it creates a variable called myVar, and it prints the value as 10. And the moment my function has been executed, it destroys this variable. And the variable which contained the value 10 is of course now destroyed, and all we have is the myVar that contains 20 from the outside. And when we print that, we get its respective value as 20. So you can also think of it like this. The myVar that is present inside this function is different to the myVar that we create outside. So the scope of the myVar within this function is local only to this function. And once the function is executed, that variable is destroyed. Alright. Now let's look at another case, or the other side of this case, where say we're dealing with variables that have a global scope. How do we deal with them? So let's create a variable called myVar. Alright. And I say I store 100 in this. Alright. Now if I define a function, I've stored myVar. Let's say I define a function. Define underscore, say again, same name. Where what I'm going to do in this is I am going to print the value of whatever is there in myVar. Okay. So let's do print value of variable is value stored in variable is. Okay. Let's myVar. So let's see what happens when we do this. Let's call this function fun underscore name. Let's see what happens here. So as you can see, the value, I stored a value 100 in myVar, and I've called it inside the function. And this is because since I've defined it outside, I can use it inside as well. Now what if I try to change the value of this variable inside the function though? So let's see. If I did this, and now if I try to print, let's see, is this allowed? No, it's not allowed. In fact, I get an error. It says local variable myVar reference before assignment. And without going too much into detail, what it's saying is that the variable inside over here is still local to this function. And I have not defined this myVar as a global variable, so I cannot make changes to it within this function right now. And to change that, I can use the global keyword. What if I did global over here? So if I did global, and now if I said, okay, global myVar, and I declare this variable as a global variable, now if I do this, now if I do the same incrementation, now let's see what happens when I'm trying to do this. You see, I get the value 101. This is exactly what I wanted, and that is because I've defined my variable to be a global variable within this function. So I can in fact make changes to it within this function. So this is how we use the global keyword and global variable. Also, just to make a quick note, there are three types of functions, the three types of categories in which we can divide functions. First one being built-in functions. These are the ones that are built into the standard library of Python. The other is user-defined functions. That is the ones which we define ourselves. And the third type is called anonymous functions. They're also known as lambda functions, and this is something that we're going to cover in a separate video. Now let's talk about the arguments that we pass in Python. So there are four types of arguments that Python user-defined functions can take. First one being default, the other one is required, then there is keyword, and then there is variable number of arguments. So the default argument is when, say, if I defined a function where fun underscore name, and I'm saying a comma b, right? But what if the user has not, say I want a default value of a and b each time when I use this function. So in the case where if, say, I don't pass a value for a and b, like this will always be used. So I can just say a is equal to 2 by default and b is equal to 3 by default. And then within this function, I will say c is equal to a plus b and then return c. So I do this, and if I say fun underscore name, and in case I don't pass any arguments here, let's see what happens. By default, I get the answer 5 because by default A is 2 and B is 3. But this is not fixed, and I can always change this by passing my own values here, 5 and 6, and in this case I should get 11, as you can see here. Now the next type is required arguments, and when we are defining a required argument, we just simply do not use the equal to sign for the parameters over here, and this basically it makes it so that now anytime we call this function, we have to pass something over here. So now if I try to pass like this, I won't get a I won't get a default value. Then that's because well, there is no default value and it needs an A and B. So I have to pass it a 3 and say 4. Now it should give me 7, as you can see. The next type of argument that we'll be talking about are the variable number of arguments. So let's look at an example here. So what I'm doing in this particular example is I'm defining a function called mySum, where I'm passing some parameter called myIntegers, and I'm doing something out here. And what this does is, it will take the values of a particular collection of objects, and that's called myIntegers. And each value, I'm going to keep adding it to each other, and I'm going to result a particular sum. I'm just going to result the sum of whatever is there. So in this case, what happens is I'm creating a list 1, 2, and 3, which contains 1, 2, and 3, and then I'm going to print the summation of whatever is there. So it should give me 6. Now the problem in this case is that each time when I'm going to perform this function, I have to create a separate list where I'm going to store these objects. But what if I do not know what exactly I'm going to pass here? What if I don't know if it's going to be a list of objects or what is it going to be exactly? Well, in that case I can use a variable number of arguments. So it's like a variable keyword argument. So what we use here is a specific way of passing keywords, and we do it like this. So I say define my underscore name, and I use an asterisk. Now I give it any name. This can be args, this can be integers, it doesn't really matter what this is. But this is the key, the asterisk here, and this tells us that whatever we pass here is now, we're supposed to create an iterable out of this, and then we can perform whatever task we want. So let's just, since I've already created one here, let's see how I'm going to use it in this case. So as you can see, I'm creating a particular variable argument function over here, and I'm doing the same task. I'm just going to keep performing, I'm going to add whatever I pass over here. But now when I'm calling this function, I don't need to create a separate list as I did over here. I'm just passing all the numbers that I want to in the form of, it's pretty much like a tuple. So I'm just passing these numbers here, and what this function is going to do is going to create an iterable out of this, and then we're going to iterate over it. As you can see, that's happening over here. And I can keep, I can just keep so since I've done it for 1, 2, 3, and 7, the summation should be 13 in this case. I can add another number here just explicitly, just like this, and you can see the value will change. And that's because this is a variable, argument method of creating a function. Now the fourth type of function arguments is the variable keyword argument. So let's look at what is the keyword argument now. So I have defined a function here called the concatenate function, and let's see what I'm going to do with this. So in this, I have passed a keyword argument. I've said that, okay, this is going to be a keyword argument function, and what I'm going to do in this is I'm going to create a blank string, and what I'm going to do is I'm going to add or I'm going to concatenate certain strings that I'm going to pass to this function. So in this example, I have passed Python and is and cool and an exclamation mark, all separate strings. And what I'm going to do in this function is I'm going to join them together, and I'm going to create one whole string out of it. Let's see what's the result. Python is cool. So this is, so of course, if I had to add something else, like Python is say cool, and say I just wanted to say hello and say one more string, I can add it just like this. I don't have to define a fixed number of arguments. I can pass any number of arguments I want, and this works exactly the same as variable. In the only difference is instead of positional arguments, we're using keyword arguments over here. Hello, bye. Like this, it doesn't really make sense, but just to show you, as you can see. So this is how we use keyword arguments. Well, this is it for this introductory video into functions in Python. I hope you learned a bit about defining functions and sort of the keywords and the components that are part of function definitions, such as keywords and arguments and docstring, for example. You also saw the different types of arguments that we can pass. Now we will be looking at the math module in Python, and we will look at some of the math functions that are associated with this module in Python. So starting off, what is this math module? Well, the Python math module is an important library or a feature that is designed to deal with mathematical operations. This math module is part of the basic Python installation, so you don't have to install this separately. To use this math module, all you have to do is import this module, and this is how you would do it. You just do import math, and this will import your math module for you to use in your programming. And in the course of this video, I will be showing you certain concepts surrounding the math module, such as what are the constants that come with the math module, some of the arithmetic functions, the logarithmetic functions, power functions, and even trigonometric functions that we can do using this math module and the functions inside the math module. So starting off, let's look at some of the constants that are part of this. So as you can see, the standard constants that are available in this module are pi, there is tau, there is Euler's number, NaN, which is a special, it's a programming specific concept, and infinity. So let's look at these one by one. So starting off, our first constant is pi. Pi is, as you know in maths, it's the ratio of a circle's circumference to its diameter, and pi is an irrational number. You know the value of pi is 3.14 something. Since it's an irrational number, we cannot define it in terms of a specific fraction, but it can be approximated to the fraction 22/7. So how do we access this pi constant? Is as simple as this. Once you have imported maths, the maths module, all you have to do is do maths.py, and it will give you the value, as you can see. So as you can see, the value returned to us is a float. This is important to note. And the number of decimal digits, the number of digits after the decimal point that we can see here are 15. And this is like a by default thing for Python, that if you call the pi constant, it will give you the value of pi correct up to 15 decimal points. So an example of where we can use this thing is, say we have the radius of a circle 3, it can be in any units, 3 meters or whatever you want, and you want to find out its say circumference. So as we know, the circumference of a circle is 2 pi r. So if I had to find the circumference of a circle in my code for some application with the radius 3, all I would have to do is use the formula 2 pi r. And to call the value 2 pi r, instead of specifically writing 3.14 something, I can just use this function math.py over here, and then I can enter the r. As you can see, it will return me the radius, as you can see. So moving on, the next constant that we will talk about is tau. Tau is similar to pi. In fact, tau is the ratio of a circle's circumference to its radius. Pi is the ratio of a circle's circumference to its diameter, and tau is the ratio of a circle's circumference to its radius. It's important to note this difference. So because of this definition, tau is always 2 times the value of pi. This is by definition. And much like pi, if you call the tau constant from the math module, it will also return you a float number. And to find that, this is the function that we use, or this is the syntax. So as you can see, this is actually 2 times the value of pi, 6.283, and even this is returned correct up to 15 places to the right of the decimal point, and this is by default. Next constant is the Euler's number. The Euler's number is it's one of the most widespread constants used in the world of in the scientific community, in the mathematical community. You will be using the Euler's number probably a lot as if you move into data science or AI or something like that. So what is the Euler's number? It is the base of the natural logarithm. If you know what the natural logarithm is, it is used to calculate rates of growth or rates of decay. And as with numbers or constants like pi and tau, even the Euler's number is an irrational number with infinite decimal places. The value of the Euler's number, in short, it's denoted by the small letter e. So this value of e is usually approximated to around 2.718. So how do we call this constant? Is simply as math.e. This is how we do it. So you get this value. Again, this is also a float, and it's correct up to 15 decimal places. So the next concept that we will be talking about is infinity. Now infinity it's more of a mathematical concept, and this is very important to note because infinity is not really a number. There is no number called infinity. It is used to define something that is infinitely large or infinitely small. So positive infinity is something that is higher than any known number to us, and negative infinity is lower than any known number to us. So this is the concept of infinity. And how do we call this function? Well, let's see what happens when we call the math function, math constant infinity. So this is how we do it. And as you can see, it will return us this, it might look like a string to you, but this is actually a special type in Python, which is not a string. This is also a float. It's a type of a float. In fact, this infinity value, it's like a special data type. It's a special data type that you can consider as an equivalent to a float, but it's not a typical float that we know, like 3.14 or 2.71. The value of math.inf will give us INF, and this INF is actually not a string, so we can confirm that over here. As you can see, when I check the type, you see it's actually a float. In fact, this was recently added in Python 3.5, a special type known as math.inf. It returns this INF data type, which is the equivalent to a float. So this is how we use infinity. If you wanted to get the value of, say, minus infinity, all you would have to do is math.inf with a minus sign preceding this constant, and you will get minus INF. Now let's check if the concepts or the properties of infinity are maintained. Like a positive infinity is greater than any number that we know, and negative infinity is greater than any number that we know. So let's just confirm this. So I will take math.inf and I will do a check. Is this greater than, say, some really large number? Something that comes off the top of my head immediately. Okay. So let's see if this is true, then this is conceptually correct. And as you can see, it is true. In fact, I can change this number to anything as large as I want. This will be true because infinity is larger than any number that we know. And similarly, if I did minus math.inf, and I checked some very small number, a very, very small negative number. So just consider some minus 10 to the power something, right? This should also be true. Sorry. It should be a smaller symbol. This should also be true because I'm checking minus infinity. It's smaller than any known number to us, and it is true, as you can see. So it's very also if you did something like, so let's say if we do let's add something to this. It's a number, so we should be able to do arithmetic on this. Let's actually see what happens when I add, say, 10 to positive infinity. It actually gives us the same value back, infinity, because intuitively we know that infinity plus anything is still going to be infinity, right? And this is exactly what Python does for us. Even if we add a number to this math.inf or the infinity constant in Python, it will still give us the same value, the same data type of INF or infinity. Similarly, if we subtracted something from the negative of math.inf, let's say minus 100. So if we subtract something from minus infinity, we're technically still minus infinity itself. So this will again give us minus and then minus INF, as you can see, and this is absolutely what we need, and this is a very, very interesting feature in Python. Finally, the last constant that we will discuss is the NaN, or the not a number constant. So this is not really a mathematical constant. There is no constant in maths called not a number. This is a computer science related concept that it's used to denote invalid inputs, or it's used to indicate certain places where, say, a variable that should have a number it's been corrupted for whatever reason, and it now has a text or a symbol, and our code throws an error. Then in these cases where Python expects a number from us or from your code and it does not get it, it will throw you a NaN value, and this is usually used in cases where you have errors in your code. So again, just to check like what this constant, like how to call it, this is how you actually do it, math.nan, and it will give you a data type called nan. Also, much like the infinity constant, let's see what's the type of this constant. Again, it might look like a string to you, but of course this is not a string. This is a numerical concept, and as you can see, it's still a float. So this is like It's another special data type that was created for specifically this case, where it's the equivalent of a float, but it's not really the typical float that we associate with. So this was constants in the maths module. So our next topic will be arithmetic functions that we can do in the using the math module. So some of the common arithmetic functions that are available to us are factorials, the ceiling operation, floor operation, there's permutations, there's combinations. You can find the greatest common divisor or the GCD and the LCM or the least common multiple, and you can truncate numbers. So let's look at them one by one. So starting off with the factorial operation. The factorial operation is done using the factorial function, as you can see here. Actually, it's defined like this, math.factorial. Alright, so now what we pass in between the parentheses will be what we calculate the factorial for. As you know, factorial is always for a positive integer, and the factorial for, say, a number 10 would mean 10 times 9 times 8 times 7, so on until the number 1. Obviously, factorial is only defined for positive integers. It is not defined for negative values, or and it's also not defined for decimal values. So let's look at an example. So as we know, so let's say we pass maths.factorial for 6, and let's see what's the value. So this is exactly what we expect. So we expect the value of 6 times 5 times 4 times 3 times 2, that is actually 720. Let's see what happens when we pass 0. This should give us 1, since we know 0 factorial is 1. Now let's see an error case where we pass, say, minus 5. As you can see, this will throw us an error because factorials are not defined for negative numbers. Now moving on, so the next function that we'll talk about is the ceiling function. So the ceiling function is defined using math.ceil, as you see here. So again, we pass the number that we want the ceiling for in between the parentheses. So what is the ceiling function? It gives you the it gives you the smallest number that is greater than or equal to what we pass over here. So for an example, if I gave you 6.6 and I asked you, okay, what is the ceiling function for 6.6? It should give you 7, because 7 is the largest integral value that is greater than 6.6 or equal to it. Obviously, if you give the ceiling function for an integer, it will give you the integer itself. So let's look at an example, 7.8. So this should give me the value 8, as you can see here. Let's look at another negative number. So minus 12.3. An integer that is greater than minus 12.3 is minus 12. The smallest integer that is greater than minus 12.3. And this should give you 12, minus 12, as you can see here. A similar function is the floor function, which is defined like this. Again, the floor function, what it does, it gives you the greatest number that is smaller than whatever value we pass between the parentheses. So if I gave it 2.3, it should give me the value 2. Again, if we pass integers, it will just give us the integer itself. Again, just to reiterate, this ceiling and floor functions, they give you integer values. So the floor function will give you the largest integer that is smaller than what we pass over here. So let's look at 6.7. So the largest integer that is smaller than 6.7 is 6. And as you can see, this is our answer over here. The next function that we will look at is the truncate function. The truncate function is defined using this. Truncate is very similar to what we have seen. This is how we define the truncate function. It is very similar to the ceiling and floor. In the truncate function, what we do is we pass a decimal value, a float number, to the between the parentheses, and what we get back is the number without the decimal component. So only the integral component. So if I gave it 7.8, for example, it will give me only the 7 part. It will return me only the 7 part, and it will chop away the 0.8 part. If I gave it minus 12.3, it will chop away the 0.3 part and give me only minus 12 back. So let's look at an example. 8.9. It should give me only 8, as you can see here. Say I did minus 8 or minus 6.9. It shall give me minus 6. So you can think of truncate function as it does the floor function for positive values and it does the ceiling function for negative values, because it rounds down and rounds up respectively for positive and negative values. So now let's look at the next set of arithmetic functions. Let's move on to permutations. Permutations are defined using this, as you know. So in between the parentheses, I have to pass two values, n and k. So I have to pass an n and a k. The k has to be lesser than or equal to n, because the permutation, as you know, is the number of ways in which we can permute from n objects, k different objects. So what this mathematically, what this is permutation of n and k is n factorial divided by n minus k factorial. So if I pass, say, 10 and 6, it will give me the permutation of 10 and 6. So let's look at what's the value. As you can see, it's this very large value, 151,200. Similarly, there is a combination function, and this is combinations and permutations are used a lot in probability. So if you're going to move into that sphere, which you will encounter a lot in machine learning AI, you will be using these functions quite a bit. So the combination function, again, you pass an n and a k. Again, the n should be greater than or equal to this k. What this evaluates is n factorial divided by n minus k factorial times k factorial. So again, this is a mathematical concept. So let's look at the the combination of 10 and 6. So as you can see, it gives me 210, which is the combination of 10 and 6. In the arithmetic function section, are Gcd and Lcm. As we know, Gcd is the greatest common divisor, Lcm is least common multiple. So as of the newest version of Python, in Python 3.9, the math module gets these two new functions that were very lately added, actually. Since I cannot show you that because I don't have the absolute latest version of Python on my system, but using the math.gcd function, this is the function, and in between this, what we would do if we had the latest version is we would pass two numbers, or as many numbers in fact, and what this function would do is find the common divisor amongst them. So if I gave these, say for example, if I gave these numbers, it would give me the value 10. Similarly, the LCM function, again added in Python 3.9, finds the common multiple amongst whatever we pass over here. So if I passed, say, 20 and 30, this will give me the value of 60, which is the LCM of 20 and 30. So again, these are it's something neat that if you say you have Python 3.9 or if you have Python 3.9 or after that, you will have access to these functions as well if you when you import the math module. So that was for the arithmetic functions. Let's move on to the next section, which are power and logarithmic functions. So let's start off with the power function. There are multiple ways you can actually do a power function in Python. So you can do something like this, which is the equivalent of 2 to the power 3, or you can use the inbuilt module math, and you can use the POW or the power function, this is how you do it. And if I had to do same 2 to the power 3, I would just pass 2 and 3 as arguments like this, and it should give me the value, as you can see, 8 over here. What if so there's actually one more function, which is simply the POW function, and this is not part of the math module. It's a function not part of the math module, but it's still part of the base Python. You can use this as well, and you can do the same thing. POW 2 and 3, it should give you the value 8 again. Now you might ask, what's the difference between these two functions? Well, it's not much. For at least in a beginner standpoint, it's not that much. Just note that the math.power function is slightly computationally faster than the simple power function. So yeah, moving on, the next topic would be the next function that we'll discuss is the exponential function, which is defined like this. Again, exponential function is again e to the power something. So if I did exponential of 3, this would give me e to the power 3. So as you can see, oh, of course, I did not define the module beforehand. So math.exp, now when I do this, it'll give me some value, which is basically Euler's number, or e to the power 3. So this was the exponential function, and let's look at an example. So we will look at the example of rate of decay, and we will use the this function in that example. So the exponential rate of decay is used to calculate the amount of radioactive elements that is present in a substance after a certain amount of time. So the expression is something like the initial amount of radioactive elements that were present right at the beginning times the exponent of -693 times t for time divided by the time period, the half-life time. So let's just write it down to make it simple. So again, as you can see, so this will give me the remaining amount of radioactive elements, right? So let's write down remaining. Let's assign this to a variable remaining. So the initial, again, initial is the initial amount of radioactive elements. So let's give it some value, say 100. The time, let's assume it's 10 years. And let's say the half-life is around, I don't know, let's give some value, say 3 or something. Again, this is the details are not important. So this will I'm using the math.exponential function over here, as you can see. And for these values, now when I check what's the value of remaining after I calculated it, it's something. So it's basically what this tells me is that I started off with 100 units of some radioactive element, and in 10 years, this is what is left. So yeah, so this is how we would use, say, the exponential function in a particular example of ours. So next type of, again, functions are logarithmic functions. So let's look at some of the logarithmic functions that are part of the math module. So a basic log function would be written like this: math.log. In between this, I would pass the number that I want the log for. By default, if I just pass one number, it will calculate the log of 8 to the base of e. As we know, e is the Euler's number. So let's see what it does in this case. It gives me some value. What if I wanted to specify a particular base? Well, I would pass a second argument in this case. I want to find the log of 8 to the base 2, and this should be the value 3, as you can see over here. There are two specific functions that are also provided in this math module, that is log2. What this will do is, again, I have to just pass one argument, and this will automatically find the value of the log of 8 to the base 2, as you can see here. Similarly, there is a math.log10 function. If I did this, I will find the value of something here to the base 10, as you can see. So this was logarithmic functions. Then finally you have the square root function. So how would we use the the square root function is math.sqrt. Again, we pass what we want over here. If we want the square root of, say, 49, this should give me the value 7, as you can see. Finally, we move on to the final set of functions that we can do using this math module. They are trigonometric functions and they are hyperbolic functions. So let's start off with some of the trigonometric functions. As we know, we can do sine, we can do cosine and tan, some of the basic functions. The way we would do it is math.sine. In between this, this is to calculate the sine of a particular angle. And this angle must be passed in radians. This is very important to note. We do not pass it in degrees, but in radians. So if I say passed sine of 3.14, as we know, 3.14 is an approximation of the value pi. Sine pi is supposed to be, in fact, it's supposed to be 0. So let's see. We get something close to 0. Again, since this is an approximation, it won't give us the exact value. Similarly, we can use math.cos to find the value of a particular angle. If you want to find the value of the cos of a particular angle, we can use the tan function in case we wanted to find the tan. Similarly, we have the next set for arc sine and the arc cosines of angles. So to find the arc sine, for example, we would use a sine. For arc cosine, we would use this. And for arctan, we would use this. The next set would be hyperbolic functions. Again, hyperbolic functions are basically the sine and the cosine and the tan calculated not circles but on hyperbolas. Again, the details you don't have to know the details. You just should know that if you wanted to say, for example, find out the hyperbolic sine of an angle, we would use math.sine h, and we would pass what we want in between this. Similarly, if we wanted to find the cosine, it would be cos h, tan, it would be tan h. And if we wanted to find the inverse of the hyperbolic inverse, what we would do is use a. So we would use a tan h. If we wanted to find the hyperbolic inverse of sine, we would use a sin h. And similarly for cos, it would be a cos h. Now we will be covering the topic of modules in Python. Now a module in Python, to put it simply, is basically a Python file that has functions and classes written into it and is saved with the .py extension to specify that it is indeed a Python file. A Python program can use one or more modules, and modules can have one or more functions. They basically help us organize our code, and instead of having one long Python file, we can have several files or several modules. Now, modular programming is the process of breaking a large event or task into smaller and more manageable subtasks, and we call these subtasks basically modules. Now, individual modules can be grouped together like building blocks to create a larger application. There are several advantages to modularizing code in a large application, and we will be going through them right now. So first of all, there is simplicity because instead of focusing on a big problem or big task, we can break down the problem into smaller portions or modules. Now, maintainability of code is much better through modules because they are designed to create these sort of boundaries or clear demarcations between different problem domains. There is reusability in the sense that once we create a module, we can use it in different parts of the code or even different applications itself. There is also scoping, and what this means is modules typically define a separate namespace, and this helps us avoid collisions between identifiers in different areas of a program. Functions, modules, and packages are basically all constructs in Python that promote code modularization. You might have already come across or gotten an intro into functions. In this video, we will be going through modules. And in another video, we will also cover the topic of packages. To import a module, we use the import keyword. And in this example, what I'm going to show you is a simple function or a simple operation of importing the OS module. This is short for operating system. And as the name suggests, we can perform system tasks through the functions and methods that are part of this OS module. So simply executing this statement will import this module onto our program for us to use. Now, if we wanted to see all the functions that are present in a module, what we have to do is use the dir function. So if we print the dir OS function, it will print us basically a directory of all the functions that are present in the OS module. As you can see here, all of these are basically names to different functions that are part of the OS module. Finally, moving on, another function commonly used with modules is the getCwd function. And what this does is it will give us the current working directory that we are working upon right now. So if I execute this, it will tell me what is the directory that I am currently working upon right now. As you can see, C notebook dir/temp. If we wanted to see all the files in a particular directory, what we can do is use the listdir function followed by giving a path. By default, if we do not enter a path inside the parenthesis, it will basically give us all the files in the current working directory, which in our case is temp. So if I were to execute this, it basically gives me a list of all the files that are presently there in the directory that I am currently working upon. Now, a basic step is creating a Python module. The simplest way to create a Python module is basically creating a Python script with whatever functions and tasks that we want and methods that we want inside whatever module, and saving it with a .py extension. So in my example, what I'm going to do is I have already created a script in Notepad, and I've stored it with a .py extension that contains these four functions: add, subtract, product, and division. I've basically used this code and I've stored it in a .py script, and I'm going to be using this as my as a test module for this particular example. Now, how do we import a module? Now, once that I have created a script, in my example, it will be called mycalc.py, and we've stored it in our directory. To import the module, all we have to do is use the import statement. So if I had to import mycalc, all I have to do is say import my_calc, and now my calc has been imported. So we can use the import statement, or if we want to import something particular from my calc, we can do from my calc import. Now we can, whatever, like for example, if we wanted the add function, we can basically just say only add, or if we wanted add and subtract, we can say add and subtract, for example. So this is basically by using from, we can say that we want something from something, but only parts of it. We don't want everything. We can also use from mycalc import, and we can say asterisk to basically say import everything that exists in mycalc right now. So this is another way way of importing something from a module. Now to access contents in a module, we have to use the dot operator, and I will show you how right now. So what I'm going to do is, in my example, I'm going to import my calc as calc. So now since this is the original folder or the original module, but I'm going to give it a shorthand name so that I can easily use it in my code and I don't have to type out my_calc every time. So now I'm going to import this as calc. So anytime I have to refer to a particular method or function inside this script or this module, I will just use this placeholder, this variable name. So now I have two variables, a and b, and I'm storing 20 and 30 in them. So my first what I'm going to do is basically 4 operations. I'm going to print the addition of a and b, then the subtraction, multiplication, and the division of these two numbers. And for each time to do this operation, I am going to use the add function that is present in the myCalc module. So to do that, I have already imported myCalc as calc. All I'm going to do now is invoke these functions using the dot operator that we are already familiar with. So I'm going to say calc.add, and then I'm going to pass these two arguments or these two variables to say that I want to add these two. And similarly, I'm going to do it for subtraction, multiplication, and division. As you can see, these are the results of my tasks. Now, if I had to do a directory operation on the module calc, it will basically give me a bunch of inbuilt or Dunder methods that are already a part of any Python script by default, such as built-ins. So if I execute this just to show you what happens when I use the dir function, it will basically give me all the functions that are part of this Python script. So these double underscores that you see are basically denoting magic methods or Dunder methods, and these are like inbuilt methods as a part of the script. And if you see here, add, division, prod, and sub, these are the methods that we have defined earlier on in our script ourselves. Now to go slightly deeper or in more detail into what happens when we do a module search, let's actually look at what happens. So what happens is when, for example, we execute the statement import myCalc as calc, as we did over here. So the steps that actually take place are the interpreter executes the above statement and it searches for this Python script in a list of directories assembled from these following sources that you see here. So it takes the directory from which the input script was run, or the current directory, if the interpreter is being run interactively, which is the case right now. Secondly, it will list all the directories contained in the Python path environment that you set up, that you can set up or you can change later on as well. And this format for Python path is OS dependent, of course, but it should mimic the path environment variable that we see in Windows systems. And then the other source or the other directories is basically an installation dependent list of categories configured at the time Python is installed. Now the resulting search path that is accessible in the Python variable system.path, this is basically obtained from a module named sys. So if I imported this sys and I did sys.path, now these are all the directories that we are going to look for when we want to search for any particular module. So if I'm doing import myCalc or import OS, it's not only going to look at the current directory that I am working on, it's also going to look at all of these directories that have been set up as you could say directories or paths in the system.path. Now we will be covering the topic of packages. Now what if we developed a very large application in Python that contains many different modules, and we have so many different modules that have similar names and functionalities, and they're all kept in or dumped in the same location, that it becomes very difficult to track these modules. What if there was a way to organize and access these in a much simpler and more organized manner? Well, packages allow us to do just that. Packages are a hierarchical structuring of the module namespace using dot notation. And this is the same dot notation that we use when we want to access methods or functions that are part of other classes or modules. So let's look at certain examples to understand what we mean. So I have a directory called pkg. This can be basically treated as what we call a package. Now in our package, we have two modules, mod1.py and mod2.py. And what we're going to store in mod1 and mod2.py are the follows. So I'm going to define a function called foo, and I'm going to print this particular statement, mod1, and then I'm going to basically say foo. And then I'm going to say in class foo, I'm going to have an empty pass command. Similarly, I'm going to define a function called bar in mod2.py where I'm going to print this statement. So basically mod1.py has a simple function where I'm going to print this statement, and mod2.py has a simple function that I'm going to print this statement. And I'm going to store them in mod1 and mod2.py respectively. And these two modules I'm going to store in the directory pkg in my local folder. Now I've already done this, so we can already get to working with this. Now if I wanted to access these particular modules from the pkg folder, I can simply use the import command and use the dot notation. So I can say pkg.mod1. So this will import the mod1 module from pkg folder. Similarly, I can do the same thing for the mod2 module from the pkg folder in the same line. So now that it's been imported, just simply execute this, and this imports whatever we needed. Now, if we wanted to perform a function that was a part of mod1.py, we can just extend the dot notation and use the function as over here. As you can see, it performs this print command, whatever it was supposed to do. Similarly, I can invoke the function that was part of the mod2 module by extending the dot notation to it in the same way. Now, another way that I can invoke I can import a package is by directly importing the package itself by using import pkg and not accessing any of the specific modules within it. Now let's see what happens when we do this. So just for this example, what I'm going to do is I'm going to restart the kernel so that the pkg modules that were already imported get cleaned away. So we see what happens when we execute this on its own. Now if you see, I have imported this. Now let's see if I can access my mod1 and mod2. Now if you see here, it's throwing me an error. And this is because simply using the import command on a particular package only imports, you could say, the package namespace, but it does not actually import any of the modules and files that were part of this package. So if I wanted mod1 from this package, I would have to actually say import pkg.mod1 directly. And I cannot simply say import pkg, and Python will not import everything that is part of a package on its own. I have to specify it myself specifically. Now I'm going to create, and I'm going to show you another type of importing from a package using the star operator. So I have this package pkg once again. Now I'm going to store 4 different modules within this package: mod111.py, mod222.py, and I've already done this. So you don't need to bother about seeing me doing it right now, because I've already created these files, and what I've done is within mod111.py I've written this statement and I've stored it in the Python script. Similarly, I've created another Python script called mod222.py, and I have basically written this in the code. And I've similarly done this for mod333.py, and I've done another for mod4.py. Now, once I have done this, I've stored these Python scripts into my package or pkg package. So now what I'm going to do is I'm going to execute this command. If you see this, from pkg.mod333 import star. So once I execute this, now I'm going to say print directory, and print directory basically will tell me all the functions that exist in my current directory. If you see here, there's this baz function that was a part of mod333 module. Now if I change this, and if I imported mod111, and if I did the same thing, you will see foo has now been added as a part of this directory. And these are all functions that were part of these different modules where I'm importing from. And that is what the star function does. What the star function will do is it will basically tell Python, okay, so the statement is saying from pkg.mod111. So it's saying that, okay, look into this directory or this package and find this module. And in this module, import everything that exists inside it up until this point. So this is another way of basically importing files or functions from a particular package and a particular specific module within that package. Now we will be covering the topic of iterators. Now an iterator in Python is an object that contains a countable number of values, or it's a larger object that contains a countable number of sub-objects. An iterator is an object that can be iterated upon, and what that means is we can traverse from each value and we can manipulate or perform certain functions or operations and tasks using each of the sub-objects or values within this larger collection called iterator. Now, when we're looking at it technically, an iterator is an object which implements the iterator protocol in Python, which consists of the methods iter and the method next. So to begin with, let's look at a simple iterator. We're going to see the example of a list where we're going to traverse through the objects of a list using the for loop. So we have objects 1, 2, 3, 4, and I'm going to print each of these values one by one, as you can see here. Similarly, we can also do the same thing for another iterable known as the string, where we can go character by character, again using the for loop, as you can see here. Another example of an iterable in Python is the dictionary. So let's say I have a dictionary where I have two key value pairs, key x, which contains the value 1, and key y, which corresponds to the value 2. Now when I'm going to do a for loop through this, by default, I will be traversing through the keys x and y, as you can see over here. And of course, the other types of iterables in Python are like sets and tuples as well. Alright, now let's look at what this iterating protocol is in Python. So first of all, we take an iterable. It's an object that contains, it's a collection of objects that contain sub-objects. And when we use the iter function, it creates an iterator out of it. So we can, one by one, we can traverse through each of the objects, and we can manipulate each of the objects that is contained in this. And anytime we want to move to the next object, we use the next function. And when we have finally completed all of the, or we've manipulated or traversed through each of the sub-objects, we encounter the stop iteration exception, which tells us, okay, there are no more objects to be manipulated or iterated upon. So as an example, I will create a list where I will store the values, some simple values, integers 1, 2, 3, 4, 1, 3, 4, 5. Okay. I'm going to create an iterator out of this where I will use the iter function. And I'm going to say this is, let's say this is called my iter. Okay. And I'm going to use the iter function as I had mentioned, and I'm going to pass my list in this. Now if you see what is my iter, it should be a list iterator at a particular memory location. Now let's use the next function to keep going through whatever is there in this. So of course the first object should be 1, as you can see. Now when I look at the next, it should be 3, then I should get 4, and now I should get 5 as I use the next successively. Now since I've reached the last of my objects in this collection, now the next time I use this next function, I should get a stop iteration exception that is raised, as you can see here. So this is the basic iteration protocol in Python. Now you might have already gone through the for loop video, and in that I have spoken in quite a bit of detail as to how a for loop performs this this iterator protocol and how it creates an iterable object out of, say, a list or a tuple, and how it internally performs the next function, and it breaks out of the for loop once it encounters the stop iteration exception. So for loops are like, they're very, very similar to your standard iterator, and they use pretty much the same protocol for its functioning. Now let's do a basic comparison of what is a basic comparison between a generator and an iterator in Python. So in generator, we use a function. We define it using the def keyword, and we define it under one function to create a generator. Whereas in the case of iterators, we use two separate functions, the iter function and the next function. The generator makes use of the yield keyword, whereas the Python iterator does not. In generators, we save the states of the local variables each time we use the yield keyword, and we pause the loop temporarily. Whereas in iterators, we do not make use of any local variables. All we need is an iterable like a list to iterate upon. We may use any number of yield statements in generators, and we do not use yield statements in iterators. Generators are not memory efficient, whereas iterators are very memory efficient. So this is like basic comparison between generators and iterators. So this was it for our introduction into iterators in Python. Now we will be taking an introduction into the concept of generators. So Python provides a generator, which is like a function where we can create our own iterator. In a generator function, we use the yield statement instead of the return statement that we use for standard functions. So let's look at a simple generator first of all. So out here I have defined a generator called my generator, where I'm doing there are three functions or three tasks that I'm doing. First one is when I'm printing the first item and I'm yielding a value 10. Then I'm printing second item yielding 20. Then I'm printing last item yielding 30. So let's see how do we use this. Now, since we know my generator is the function, it uses the yield keyword. Every time we use the next keyword, we will keep getting what is next in this function. So let's store the generator in mygen. So now we have stored the iterator in this function variable called gen or gen. Now let's see, when we do next and we use gen, what happens. So the first task is performed, or the first iteration is performed, where we get this, the first yield command is done. Alright, let's see what happens when we do next again. Next gen. Now, as you can see, we get second item and we get 20. Let's do it for the next, let's do it once more, since there is one more task, there's one more iterable inside. You can see this. Now a valid question is, what will happen if we do next gen again, since there is nothing after this? Well, let's see what happens. We should get an error. As you can see, stop iteration error. This is another built-in exception that happens when we have reached the last object of an iterable. So we get a stop iteration error. So now a key difference between a generator and a function is that when we execute a function, the moment we hit the return statement in a function, or when we execute a function, like whatever variables that were stored inside are lost and they're destroyed unless they were defined as global, and the function is completely done executing and we leave the function completely. Whereas when it comes to a generator, when we hit the yield function, we don't actually completely leave this function. So the first time the yield is found, we get 10, but the generator remembers its position inside this function. So the next time we use the next, we actually move on to the next iterable, and then we move on to the next iterable. So you can think of a generator as it sort of has memory, if that makes sense. It's a way to create iterables in Python, or create iterators in Python. So to understand what the difference between the yield command and the return command does, let's take the same function. Alright, and let's put a return over here after this particular, the second yield. Okay, let's do the same thing. We say gen is equal to my generator, and let's start doing next gen and seeing what's there. So the first yield will be standard, first item 10. The next one is going to say second item and then 20. But now if you notice, there was a return I put over here. So technically when I did the second next, it's not only yielded 20, but it's also executed this return function, or this return statement. So let's see what happens if I do next again. As you see, I have gotten the stop iteration seemingly earlier than I did before. And that's because I have used the return function and return statement. And what that's done is that we've completely left this function, so as to speak, and there is nothing next, so as to speak. So we get the stop iteration, and that's the difference between yield and return. Now in the next example, I'm going to show you how we use a generator function in place of the for loop, or for a for loop. So let's take this, what I have over here, and I have defined a function called getSequence up to x, and what this will do is basically it will keep printing the printing numbers up until whatever we have entered in place of x over here. So if I said, say, sequence is equal to, let's copy this, all right, and say I want sequentially, I want every number up until 10. Well, not including 10, of course, because Python starts with 0, right? So let's do this, and now let's see. So the first number will yield 0, and now if I did this again, it should give me 1, 2, and I can keep going until I will stop at the value 9, as you can see here. So 8, 9. Now I should get the stop iteration error, because that we have reached the end of our iteration. So this is a way of using generator functions for loops. So another neat example where we're going to use a generator is in the case of Fibonacci numbers. So let's use it. Let's see how we can generate a Fibonacci series using generator. So I've defined a Fibonacci function called Fibonacci where I'm passing max. So max is basically the max value that I want, like up until where I want the sequence, right? So this is basically the code which will return me the subsequent values of my Fibonacci sequence. So let's pass this to fib and say I want all the Fibonacci numbers until 10. So I will pass 10 over here. Let's see what happens when we do next fib. Well, it should start with 0. Then when we do this again, we get 1. Then we do 0 plus 1. It should be 1. Next number should be 1 plus 1, which is 2. Then we should have 2 plus 1, 3. And then 3 plus 2, 5. Then 3 plus 5 should be 8. Now 8 plus 5 is 13. And since 13 is greater than what we passed for our max value here, now when we try this, we should get the stop iteration error, as you can see. So yeah, this was a brief video into generators in Python and how we can use generators to create our own iterator function. So of course, it's very important to note that generator functions use the yield statement instead of the return statement, and that's how we differentiate a standard function from a generator function. Now we will be covering a sort of a project side type of scenario, which is basically going to be a problem case for you, and it's going to be slightly difficult, slightly tricky. But what we're going to do is we're going to tackle a particular problem, and we're going to what I'm going to do is also show you a solution to that problem. So let's start with this. So this question that we have is, we have this program that we have to write where we compute the frequency of words that exist in some input. Okay. The program should output after sorting the key alphanumerically. Now this input can be it's basically a block of text, right? So in our example, we have, for example, if this was our input, right? What we want to see is an output which is basically saying that the word Python has appeared, say, well, in this example, it's appeared 5 times. And then the word read has appeared 1 time, and so on and so forth. Like for each of these words, we want to see how many times have they appeared in this particular block of text. So let's look at a particular example now where we have done this. So let's see here. So first of all, I'm going to create a dictionary. So why am I creating a dictionary is because I'm going to use each unique word as a key and the number of times they have appeared in a block of text as the value to that key. So I'm going to use a sample string, which is basically this long string that you can see here, which is stored in line. So this large chunk of text is what we're going to be analyzing. So how are we going to do this? It's pretty simple. So we have this. Now what we want to do is when we find one way of tackling this problem that we're going to do here is we want to check word by word. First of all, we want to see if it's a unique word, and if this word is, before I encountered it for the first time, then we need to store a new key in our dictionary called frequent table or frequency table. And if it has already, if there is a key already with that particular name, then we just want to increment the count or the value by 1. So let's see how we do this over here. So if you can see in the solution is as simple as this, but if you see what's happening, it's basically what it's doing is we're splitting up this string using the split function. What this will do is it will split up the string at every white space. So it will take this as one part, it'll take this part as another part. It will create an iterable with each word as the each iterable object in that container. So it's going to be a list of words like Python is 1, so on and so forth. And we're going to go one by one. So we're going to say for word in line.split. Now if this word if it exists in frequency table as a key, then what we're going to do is we're just going to increase the count of the value of that key by 1. But if it does not exist, then we're going to actually create a key with the word as that unique word, and we're going to create its value, initialize its value to 1. So when we execute this, now if we want to, once we've done this, we can sort it by the count of the words. So what we're going to do is we're going to create another tuple called sorted tuples, where we're going to use the lambda function out here to sort the dictionary in terms of its values. So what we're going to do is we're going to take the key being the lambda item with index 1. Index 1 is basically the value. So a particular key has a value. So the word Python appears so many times. The word, say, scientist appears so many times. So we're going to check which words have the highest number of occurrences, and we're going to sort it in a descending order. So that is basically what the reverse is equal to true does. So when we're going to sort this, when we're going to use the sorted function, when we say reverse true, it tells the sorting function to sort this dictionary frequency table in terms of value by the descending order. So whichever word appears highest, that would be the first word in our sorted tuple. So that's what we do in this line, and once we execute this, we're also going to print. So if you see the result of this activity that we've done, you can see that the word machine appears 6 times, learning appears 6 times, then Python appears 5 times, and so on and so forth. So we've created a sorted tuple where the first object of the tuple, we've created a list of sorted tuples where the first object of the each tuple is the unique word. The second one is the number of times that it has appeared in this particular example or this particular string. We will continue with what we started in terms of our project number 1. What we're going to do is we're going to tackle another slightly complicated a question or a situation. We're going to try to arrive at a solution. So in this, what we have is some sort of a robot, a moving robot, which moves on a Cartesian plane, a 2-coordinate plane, is going to move in terms of up, down, left, and right. Okay, and each time it moves up or down or left or right, it takes a certain number of steps in that direction. Integral steps, of course. So what we need to do is from its starting position, whatever its starting position is, which we're going to take as 0, 0 in this example, we're going to make it move to a particular location with the commands up, down, left, and right, followed by certain steps. And we're going to what we're going to do is we're going to calculate the distance between these 2 points. And we're going to calculate different types of distances. So you might be introduced to new concepts, new distance concepts in this video as well. So what we're going to be using for distance calculation is the Minkowski distance. And that is, we're going to take, so the Minkowski distance between 2 variables is basically the absolute difference between these 2 variables, so these 2 points, and we take it to the power of something. So if we want to say calculate the Minkowski distance with, in terms the quadratic Minkowski distance with basically P2, so we are going to do xi minus yi, absolute difference to the power 2, and then we're going to take the second root of it after summing each and every point. So when we take p is equal to 2, we say the Minkowski distance behaves like the Euclidean distance, and this is probably one of the most common distances in case you've done basic Cartesian geometry. When you're asked to find the distance between 2 points on a plane, we can also take the absolute distance where we take p is equal to 1. So in this case, we're just basically summing the absolute distances between each point. No roots, no powers, nothing. Basically p is equal to 1, and we call that the Manhattan distance. So we're going to take p is equal to 1, 2, and 3 in each case, and we're going to find the distance between 2 points based on these measures. So this is just a visual representation. This is basically the Euclidean distance, is basically the estimate of the value between these 2 points. If since this is a 2-coordinate system, whereas the Manhattan distance would be the absolute distance in terms of if we go up and then we go right between these 2, like say if this was and this was another point. So yeah, let's move on to the problem. In this particular example, we're going to start from the starting position 0 and 0 on a graph. And we are going to give the commands of up 5, down 3, left 3, and right 2. So first of all, what we want to do is we initialize the starting position as 0 and 0. And we also, just for the sake of this example, we initialize the end position as 0 and 0. So what we're going to do, first of all, is, let's execute this much. Now we have this list of tuples. We're going to call this actions, and this is the actions that we're performing. So each tuple contains an action and the number of steps in that direction. So it contains 4 actions: up by 5 steps, down by 3 steps, left by 3 steps, right by 2 steps. So now we're going to iterate over this each tuple, and we're going to get the direction first of all in this line for each step, and we're going to calculate the number of steps it takes. So for each action, it's going to first tell, it's going to check what is the direction, which is done by this line, and we're going to find out the number of steps in that direction, which is stored in this line. So once you've gotten this, for each action, we have to update the end position, right? So what happens is if you go up by a particular direction, so you are basically changing the y-axis, right? The y-axis. So we're going to change end position and the first index, which is basically this part of the end position coordinate point. So we're going to say if it's moving by up, then we're going to update by adding the y-axis by the number of steps. So and if the direction was down, we're going to do the same thing for the y-axis, but we're going to decrement it. Similarly, if we move left or right, we're moving the x-axis, right? So we take end position in the first index. So we take the x-axis, and if we're moving left, it's a negative, it's a decrement, and if we're moving right, it's an increment. So if there's any other action, like any other action, for example, that was given here, we say pass. So basically the only valid actions that we can pass is up, down, left, and right. Otherwise we just skip that particular action. So this is what this particular loop will do. It will update our final position. So once we've done this, if I execute this, what will get stored in the end position is basically my end position. So now that I have my starting position and my end position, just to show you what the end position will look like right now, let's just do this. So if you see here, after I've moved up by 5 steps, down by 3 steps, left by 3 steps, and then right by 2 steps, my final end position is -1 and 2. My start position, on the other hand, was, as you remember, it should be 0 and 0. It is 0 and 0. So now we're going to find the distance between 0 and 0 and -1 and 2. So we're going to first of all create a function called Minkowski distance, which does a basic function of just calculate the difference between the, what do you say, the end position x coordinate and the end position y coordinate times or to the power of a root. And we're basically going to do this operation that you saw here. We're going to do this, and we're going to use this root variable to specify to p is equal to 1, 2, or 3, like what p value we want to take for this Minkowski distance. So once we've done this, what this function will do is basically store this much, and it will wait for us to basically wait for us to give us a root. So when we give root 1, it will create these, it will check the distance between the end and the starting points with the p value of 1. If we gave it 2, it will calculate Euclidean distance with p value 2. Similarly for 3, and we can calculate for any roots. So we're going to calculate for 1, 2, and 3 roots, and we're going to see what values we get in each case. So when root is equal to 1, I print a statement saying Minkowski distance with root 1 is something, and then root 2 is something, root 3 is something. Let's see what results we get. So if you see here, the Minkowski distance with root 1 is actually 1.0, but the Euclidean distance between these 2 points is 2.23, whereas the cubic Minkowski distance with with root 3 is 1.91. So you see these 3 different distance measures for the same distance between 2 points. So in this video, basically by doing this activity, you will learn how to how to iterate through loops and perform these distance calculations, which you'll find pretty handy in many activities related to data science and machine learning. We will be continuing tackling different problems and problem cases in terms of a project called Project 3, where we're going to be using regular expressions to validate whether certain passwords that have been entered, do they match certain criteria or not. So let's look into our particular question. We have a website that requires users to input username and password to register. Now we have to write a program to check the validity of passwords input by the users. Now the criteria that the passwords have to follow are that there's at least 1 letter between A and Z and 1 number between 0 and 9. The third criteria is that there's at least 1 letter between capital A and capital Z. So this first and third point basically is saying that there should be 1 lowercase letter and there should be 1 uppercase letter. Now there should be at least 1 character from $, hash, or the @ symbol. It should have a minimum length of 6 and the maximum length of 12. So when whatever passwords that we enter into our example, they must be comma separated. So if we're going to have an input, they're going to ask us for an input where we're going to have to input the different passwords in a comma separated way. So let's look at how do we tackle this. So for my example, I'm going to use these examples in terms of these are my password examples. If we're going to check if these are valid passwords or not. So let's copy this first of all. And now let's import the RE, which import RE is basically the regular expression module. Now in this step is going to ask us to input the passwords, as you can see here. So I will just Control V. So since this is comma separated, what it will do is it will split up each of these by the comma, and it will store them in a list. So it will take this as one password, this has another password, this has another password, and this has another password. Once I press enter, now if I want to check what's in list, what's in items, what I can do is just check over here what's in items. It's a list of whatever passwords I had entered. Each object is separately treated now in this list. Now I'm going to create an empty list called value first of all. Once I've done that, I'm going to move on to the next step. So once I've created my list called value, what I'm going to do is now I'm going to search and I'm going to check for each condition using regular expressions for whatever criteria that we have initially. So if you see here, what I'm going to do is first iterate by each item in this to check for each password. Now my first check will be a basic check for the length of the password. If it's lesser than 6 or greater than 12, then our password is illegal, so we can't be using this, and we will just continue and we won't check for anything else. But if it is within 6 and 12, the length 6 and 12, then we can continue with our check. So we'll do an else statement for pass, which basically moves on to this next block. Now once we've done this, what we will do is this first statement, what this is going to do is going to do an re.search. And re.search, as you know, is going to look for at least one instance of a letter occurring between A and Z. So this re.search followed by this. Now this is the regular expression that we have passed, and what this tells us is basically the square brackets, we're looking for anything between A and Z in terms of small letters. So if this condition is not met, then again we continue and we leave this particular search because one of our criteria is not met. Alright, but if it is met, then this if not statement will not we won't enter this block and we can move on to the next check. So now we move to elif not. Now again we're using if not statement. So this is basically checking for a negative case. So anytime one of these cases have been met, it basically means that our password has been invalid because these conditions are not being met. So we're trying to eliminate all of these conditions so that we get a valid password. So again we move on to the next statement, which is basically going to do the search for numbers. Once again, if we find a case, a password without any numbers, we continue and we don't check this password no more because we already know it's an illegal password. Now next check will be for capital letters A to Z, and the next check again will be for these particular symbols, the $, the hash, and the @ one of these three symbols. We're going to search for a white space character. So if we actually do find a white space character in our password, that's an illegal password and we're not going to continue checking for those cases. So this is basically all our cases: lowercase letters, numbers, capital letters, one of these three symbols, and the existence of a white space. So once we've done all these checks, if none of these have been passed, we move on to this else statement where we just pass. And what we can do is we append the value p to the list called value. So basically what happens is, just to go through it again, if this condition is not met and this condition is not met, this is not met, this is not met, this is not met, and if this is also not met, then we're fine. So basically, as long as we have small letters, as long as we have a number, as long as we have a capital letter, as long as we have one of these three symbols, and as long as we don't have any white space characters, we can append p to this. Otherwise it will continue and it will break out of this for loop completely. That's what the continue statement at the end of each of these blocks checks. Anytime this condition is met, this if not condition is met, then we break through this whole for loop and we don't append p to the value. But if we actually get to this stage, then what we can do is simply append p to value. Now finally what we are going to do is we're going to print out all the valid passwords. So just by a quick look, you can see here this is a valid password, right? So let's execute this and let's see what we get. If you see here, we only get one valid password, and let's look at why. some of these turn out to be valid. So if you look here, all of the conditions are met. It has a capital letter, it has a small letter, it has at least one number, and it has one of the symbols, either $sign or the hash sign or the @ sign. In this case, we have two white spaces, one over here and one over here. So this is an illegal password. Similarly, in this case also we have an illegal password because it begins with a space. In this case, it's the same thing. We begin with a space, and also it does not have any of those symbols that we were looking for, the $ or the hash or the @. So again, these three are illegal passwords and they do not get appended to value. However, this does get appended to value, and that's why we get the result for only one password, which is the only legal password. Now we will be learning about the concept of list comprehension. Now, list comprehension it's a neat way of creating a new list based on values that are already there in an existing list. So you can think of it like creating a new list using a much shorter and cleaner syntax compared to what you might traditionally be thinking. So let's go through some examples, and through those examples we will see how list comprehension makes creating these new lists much simpler and much easier for us. So in our first example, we will be creating a new list which will contain fruits that contain the letter A in their name. So we already have a list of fruits over here, as you can see. It has apple, it has banana, cherry, kiwi, and mango. Now we want to create a new list which has only the fruits that have the letter A inside them. So apple would be one of them, banana would be one of them, and mango would be one of them. So traditionally, if you look at this piece of code, this would do what we want to do, but this contains a few extra lines. But yeah, it does do what we want to do. Now what if there was a way of doing the same thing by just writing one simple line of code? And that exists, as you can see here. So I take the same list. Now this is where you need to follow. So now my new list is equal to, so I'm creating a list over here, as you can see. Now within this list you have this line. This is what we call a list comprehension. So as you can see, it says each fruit for each fruit in fruits if, now it's checking for the letter or the character A inside each fruit. And what this each fruit is, that we're checking each object in this list one by one. So first, in the first iteration, each fruit will contain the string apple. Then in the next iteration, it will contain banana. And in each iteration, we're going to check if it contains the character A. And if it does, then we store that each fruit in the new list, as you can see here. So if I execute this line, you see my result is the same. I have my whatever I wanted. And this was a much cleaner way of writing or creating this new list. Let's look at some other examples now. So my next example, what I'm going to do is I am going to iterate through a string. So I have a string. It can be anything. In this case, I am using a string called human. All right. So I have a string called human, right? Now I want to store each character of this string into a list that we call h_letters. So if I use the for loop, this is how we would do it. If I execute this, as you can see, the list contains h and then u, m, a, and then n. Now what if I wanted to do the same thing but by using list comprehension? So what I would do is, let's create a list over here, h_letters, and so as we know, list comprehension will you just basically need one line. In this case, it will just be like this. Now this is my string. Now let's see, when I check what's in h letters, let's see what is the output. So as you can see, I have the output as what I needed. So this is a much cleaner way. Let's go through some more examples now. Now we can do more list comprehensions. We can even use, so we've already seen one case where we checked for the character A. We've seen a case where we went through, where we did a sort of a loop through a string. We can also use list comprehensions in conditionals. So let's look at an example where we use the list comprehension with an if statement. So what if I wanted to store, say, the first 10 even numbers? So this is an example that I'll be using. So in my list, I want to store the first 10 even numbers. So this would be a way to do it. So I have in range 20. So what this is going to do is x is going to take the value of 1, 2, 3, 4 and so on until 90. It'll actually take it from 0, 1, 2, 3, 4 until 19. So when we do range 20, we're creating an iterable where we're going to loop through or iterate through the values 0 to 19. So if I do this, and this what this statement does is basically it checks if it's divisible by 2. So if this is equal to 0, that means we have an even number, and if this condition is met, that means we store the x into our number list. So let's see what happens when we execute this. This should contain 0, 2, 4, 6 until 18. So this is the first 10 even numbers, as you can see. So this is a neat way of using if statement. We can also use an if else statement. So what if I'm checking each. Okay, so I'm going to create another list, and in this list I'm going to basically see if each of my numbers are the even or odd. The first, let's say 10 natural numbers. So let's write this statement down. So I want it to be even in case the I that I'm checking, I being every number between, like say the first 10 natural numbers, as I said. Now let's check if it is divisible by 2. Well, if it is divisible by 2, of course it's going to be even, right? Else we say that it is odd. And then we check for I in, say, let's say the first 20. Okay. So now when we do this and we check what's in the list. So as you can see, the list contains like even, odd. It's basically saying the number 0 is even, then the number 1 is odd, then number 2 is even, and so on and so forth. So this is an example where we used the list comprehension with if-else statements. So another neat thing that we can do with list comprehensions is that we can use it along with functions. So let's look at this function. In this example, we have a function called double x, where we define this double function to take an input, to take an argument x, and what we return is the square of the argument. So let's use this in our list comprehension. So what we do over here is that we're checking. What we're doing is for every x bit in range 10. So we're taking the value 0, 1, 2, 3 until 9, and we're passing it to this function double x, and we're going to get the square of them, and we're going to store that in a list, as you can see here. Let's call this list x. Let's just call this list let's call it y. So now let's see what's in y when we check. It should be 0, 1, 4, 9 and so on. So wait, let's check again. Does this square? No, this is actually 2 times. So let's make it square, as you can see. So you can see 0, 1, 4, 9 for the first 10 numbers, 10 natural numbers. Now what I've shown you is obviously list comprehension, but we can also do set and dictionary comprehensions. In fact, set comprehensions work exactly the same way as list comprehensions. The only difference is the set comprehensions will make sure that there are no duplicates inside the set. So you can't have like duplicate items, which you can in the case of list comprehensions. So let's just take a look at an example. So here in this example, what we're doing is we're going to check. So we have this string that we're storing in the variable text, and the string is something like life finds a way. So whatever this is. Now what we're going to do is we're going to iterate through this string character by character, and we're going to check if we're going to check for vowels essentially. So we're going to see if the character A, E, I, O or U is present in the string, and if it is, we will pass it into our set. Now if you look, you will find there are multiple I's, right? And there are multiple A's as well. So if we did this through a list comprehension, each time that we find a vowel, it would be added to our list. But since this is a set, and sets do not allow duplicates, so you will only have one copy or one particular object for each of the vowels. So of course now set comprehension is defined using curly braces, so let's keep that in mind. So now if I check what's in this, I will see A, E, I and U. Even though there are multiple A's or multiple E's or I's and U's, since this is a set, we don't have duplicate copies of any of these. So this was just a small example for showing you set comprehensions. Similarly, we can do the same thing, this comprehension for dictionaries, and we call it dictionary comprehensions. The only thing that we have to worry about when it comes to dictionary comprehensions is that we have to define a key when it comes to this. So let's look at an example. In this, what we're doing is, again, dictionary comprehensions are also defined using curly braces, just like sets, except in this case, we will define a key, and that separates it from a set comprehension. So in this case, what we're doing is that I'm checking, I'm going through a list of numbers from 0 to 9, right? This is what the range 10 function does. And what I'm going to do is, I'm going to create a key, which is going to be like 0, 1, 2, 3. And the value of each key would be its square, as you can see here. I'm doing I times I, or just to make it a little more clearer, as you can see, I'm doing I square over here for every value from 0 to 9. So what I should get is like a dictionary where the first key is 0 and the value of that key should be 0 as well, because 0 square is 0. Then for 1 it will be 1, and then for 2, 4, and then 3, 9, 4, 16. So let's see what happens. As you can see here, this is the result that I wanted. So just to summarize, let's go through some key points to remember when it comes to list comprehensions. So it's obviously an elegant way to define and create lists based on existing lists. It's more compact and faster than normal functions and loops. But we should also keep in mind that we shouldn't write like very complicated list comprehensions, because the idea of a list comprehension is to be user-friendly. And also, it's important to note that every list comprehension can be written in the form of a loop, but every loop cannot be written in the form of a list comprehension. And that is probably a very key point to remember. Now, we will be learning about the concept of regular expressions. Now, a regular expression is simply a sequence of characters that defines a search pattern. For example, if you see this example here, you can see a symbol called the caret followed by P and then 5 periods, then an N and a $sign. And what this regex pattern does is it's searching for a 7-letter string that starts with P, ends with N, and has 5 characters in between. Let's look at this example now. This is a regex pattern that is looking for a 5-character string that starts with A, ends with S, and has 3 characters in between. Now, if we had to match this with this string, with these strings as our test strings, the first one would not match because it's a 3-letter string and we're looking for a 5-character string. The second one would match because it's a 5-character string that ends with an S, starts with an A, and has 3 characters in between. This will not match because what our pattern would do is it would find the first S, and it would find that the string itself starts with an A, and it would say, okay, there are only 2 characters between this first S and this A, and it would assume that this is actually just a 4-character string. To actually identify 2 consecutive S's, we would have to do something special, and what we would have to do is what we will see later on. So again, this is the same example. Since this is case insensitive, capital A is perfectly fine when we're searching for this, and it will also match. This is obviously 2 words, and it's not a 5-character string, so this will not be a match. Now, the regex pattern or the regular expression module in Python can be imported using this statement, import re. Now, once we've done this, we can actually use our regular expression tools and methods to do pattern recognition, character recognitions, and to identify different sequence of characters in our strings. Let's try to understand a bit more in depth about regular expressions now. So what you're seeing here is one variable called pattern, which stores something that looks like a regex, and another variable that stores our test string called abis. Now what we're going to do is we're going to use the match method of this module re, and we're going to check whether this pattern or whatever we are trying to search using this regex is in fact, does it match with our test string. And what we're trying to look for is, if you see here, very similar to what I just showed you, a 5-character string that starts with A and ends with S. So if you see our test string, it indeed is a match, and when we use this command, we should get a perfect match. So we should basically it should say that search is successful if I execute this. And this is what it does. Now if I change the test string to this now, you will see that now this is no longer what we are looking for, a 5-character string with A and starting with A and ending with S, and you will see that the search will be unsuccessful, as you can see here. Now let's try to understand what exactly do we mean by when we use these special symbols, like for example this caret or this dollar symbol. These are, by the way, known as meta characters, and now we're going to look into all the or most of the different meta characters that are used in regex. So to put it simply, meta characters are simply characters that are interpreted in a special way by the regex search engine. Now here's a list of meta characters. Let's go through them one by one. Now the square brackets. Square brackets simply specifies the set of characters that we wish to match. So we want to match some combination of A, B and C. It can be 1A, 2A's, 3B's, 4C's. We are not looking at a specific pattern. We just want to know if A, B and C exists in any form in our string. So if we used it on A, the string A simply, we would find one match because the letter A is found here. AC would match twice because we have A and C present here. In this string, Hey Jude, we will have no matches because A, B and C, none of them are found here. And in this weird string, we will have actually 1, 2, 3, 4 and 5 matches. So we would have 5 matches for this this bigger string because we have 5 instances of A, B or C. Now let's use re.match to actually search for this and to see if we have our particular whatever patterns that we're looking for. Now in this input string, this is just some example string. I'm going to test this. I'm going to match whether my pattern that any of A, B and C, is it actually found in this. So let's see what happens when I use re.match for this. So the format, the syntax is simply the regex pattern and then comma whatever test string that we have. So let's see what object gets created when we try to do this. As you can see, it's none. Even though you might be wondering, like I can see an A over here, I can see a C over here. re.match actually gives us the result none. Now, if I try to do it on this test string, which is slightly different, instead of the film Titanic was released in 1998, what I'm saying here is all film Titanic was released in 1998. Now let's see if the R-match works or not. As you can see, it actually does return. When I execute this, it returns us an object called re.match object with a span 01. The span 01 is basically telling us that we have found a match between the 0th and the first character, which is basically this character A, which is what it has found. And it's saying that the match is indeed the character A from amongst these options. So what this is basically telling us, and what this means actually, is that the re.match method will only find matches if they occur at the start of the string being searched. Once there is a space in our bigger string, it will not search for whatever comes after it. So what happened in the first instance was, it was actually only searching for matches in this particular word in my larger string. And since it found no match, it basically gave us the result none, which was not the case in the second example because it found a match immediately in the first letter A. Now, if we want to actually check the whole thing, what we would be using is the re.search. As you can see here, the re.search method will actually check the whole string and it will return us the first instance where it finds a match. Now let's see, this is the test string now, and we're searching again for we're searching for A, B and C, any of these in our test string, but we're going to use re.search and not match. So now if you see, it returns us, when I execute this, it returns us a match object again, but this time it's saying the span of 9 and 10. Now the span of 9 and 10 actually exists over here. This is the 9th character and A itself is the 10th character over here. So what this basically is telling us that the 10th character is where we found a match, which was the letter A, which was the first instance of either A or B or C in this whole string. And this is basically how re.search works. It will not only search the beginning of the string, but it will search the whole string and return us the first instance of wherever we find. Now what if we wanted to find out all the instances wherever A, B and C were found and not just the first instance? Well, in that case, we would be using the method findAll over here. So when we use findAll, it will actually return us each and every case where it found A, B or C. And you might not, it won't tell you the exact position, but it will tell you like, so if I execute this, you can see it gives us a list with A, C, A, and A. And what this basically means is it was looking for the characters A or B or C, and it found A first, and hence this for the first item in the list. And then it found a C, and then it found two A's successively. So this is actually how find all works, where it will actually find all of the instances of our regex pattern. Now that you've seen how the square brackets work and how the re.search and re.match and re.find all methods work, now we're going to go through all the other meta characters that we saw above. So the period. Now period matches any single character except the new line. New line is basically /n or a break. Now if you look at this picture, what it's going to do is this expression basically saying that do we have two characters, like sets of two characters in our string. So this is a single character string, and obviously a single character string is not a double character string. And this expression, this double dot, is basically asking us, do we have two characters present in our string? So if I had to match it with this A, it will obviously be a no match because A is one character. If we checked it with AC, it is a match because A and C are two characters. A, C and D will also give us only one match because it will find A, C and then it will leave D as a single character. But when we check A, C, D and E, or this string in particular, it will find two matches because it will consider A and C as one of the matches and D and E as one of the matches. So below is basically what we're doing. Basically the same thing, we're just using rd.search for each of these different examples. So if you see when I use find all on A, C, D, E, and when I'm searching for a two character match, you will see that it will return me A, C and D, E, as you can see here. And similarly for something like this, it will return me again whatever like two character patterns it finds successively. So the next symbol, the next meta character, is the caret symbol that you've seen earlier. And the caret symbol is basically used to check if a string starts with a certain character. So if you look at this picture, we have two expressions that we're going to check over here. One is checking if A is the beginning of a string, and the other one will check if A is the beginning of the string, but is it followed by B or not. So when we check this, what you can see is the first string will be a match because it's only the character A, and it will match here as well because this string starts with A, but it will not match here because this string starts with B. Now if I look at this particular expression, you can see that this is going to search for if the string starts with A and is followed by a B. So it will match in this case because it does start with A and is followed by a B, but it will not match in this case even though it starts with an A because it's not followed by a B. So out here is basically us using the re.search to basically find these patterns. The next symbol that we will come across is the dollar symbol. So the dollar symbol that you can see here is used to check if a string ends with a certain character, and we've already seen how this is used in one of the earlier examples. So this is going to check basically this expression will check if the string ends with A. So this string is basically the character A, so it will match. This also ends with A, so it will match. And this particular string does not end with A, so it will not match. And we are going to do that using the re.search over here. So as you can see, it finds a match in the first character itself here. In this case, it finds a match in the last character, but in CAB, there is no match, so it returns us a none. Another example is of the meta characters is star. So this is the symbol for star, and what the star basically is used is for checking if there are 0 or more occurrences of the pattern to the left of it. So now if you see here, what this will check for is there any form of M and A that occurs before N? And it's very important to note that the N has to follow the A in this case. So let's look at these examples and what will happen. So if I checked it with M and N, this is actually a match because N is followed by 0 occurrences of M and A, which is, it might seem a little weird, but it is technically the truth, because the star symbol doesn't check for the existence, it just checks for if N occurs, it must occur after an A, or the A should not be there itself in this particular string. So as you can see here, the N occurs after an M, and it's fine because there is no A. Now you will see when it will not work. So M, A and N is obviously fine. M triple A N is also fine because N follows an A and there's an M here. This, however, main will not match. Now why? Even though we have M and A and we have an N, you see the N is immediately followed by an I. N follows an I immediately. or the n is preceded by an I immediately. And this is a no match because the strict condition in the search is that n must precede an A if the A exists. Again, in women it will match because n follows an A over here. We're just going to use the re.search for these examples that we saw over here in terms of code using the re.search, as you can see here. Finally, we have the next meta character, which is the plus symbol. Yes. So the plus symbol matches one or more occurrences of the pattern left to it. Now this is very similar to what we saw earlier in terms of the star, except now in the plus, the key difference is we're looking for one or more occurrences instead of 0 or more occurrences that we were looking for in the case of star. So when we say one or more occurrences, now we need what is there to the left of the plus sign. A 0, no occurrence of it will not be allowed or will not cause a match. So let's see now what we're going to do here. We're going to use the same expression, except we're going to replace the star with the plus sign. So now what we're going to say is, okay, we need m and a, at least one occurrence followed by an n. All of these conditions have to be met. So again, if we took the first example, m and n, this time it will be a no match because there is no occurrence of an a over here for preceding the n. So it's a no match. M, a and n is a match because, well, this is perfectly fine. M, triple a and n is also perfectly fine. But if you look at m, a, I and n, much like earlier, the n is preceded by an I and not an a, so there is no match. And again, woman is perfectly fine. And we basically execute the same thing through the search function in this piece of code. The next meta character is the question mark. The question mark symbol matches 0 or 1 occurrences of the pattern to the left of it. So let's see what this does. So now we saw the star which was 0 or more occurrences of the pattern to the left of it. We saw the plus, which is 1 or more occurrences of the pattern to the left of it. Now we will see the question mark, which is 0 or 1, only 0 or only 1, and not 0 or more or 1 or more, which was the previous cases, only 0 and 1 or 1 occurrences of the pattern to the left of it. Again, we're going to see the same expression, except we're going to replace the meta character with the question mark. So now let's see what happens when we match. So if you see here, m and n is a match because there is 0 occurrence of a and 1 occurrence of m preceding n. So this is fine. This is also fine because there is 1 occurrence of a and m, and then it's followed by an n. This will not be fine because now we have 3 occurrences of a, which is followed by an n. We're only looking for 0 or 1. This again, main will be a no match for the same reasons that we have already gone through, and woman will be a match again for the same reasons. And we do the same thing using the search function in this piece of code. The next meta character is the braces character. Now the braces character is interesting because what we're going to do is we're going to see if there are, the typical syntax for a braces is n brace followed by some integer n, comma, integer m, and then close braces. So what this means is we're looking for at least n and at most m repetitions of the pattern left of the braces. Let's see through an example. If you see this expression, we're looking for at least 2 and at most 3 occurrences of the character a in our test strings. So let's see what happens in the first case. We have no matches in this case because this part of the string contains only one a, and even this part of the string only contains one a. We're looking for at least 2 and at most 3. This part will contain one match, the second example, because the second part of the string actually contains 2 a's for two repetitions of a's consecutively. But this in the third example, you can see both the strings actually contain matches, so we get 2 matches because, as you can see here, there's 2 a's here followed by 3 a's here. Now when we look at this particular string, let's look at what happens now. So what we're going to find is that this thing is perfectly fine. So we have 2 occurrences of a, but now we have 4 occurrences of a. But what the search engine is going to recognize is these first 3 a's, and it's going to see, okay, so there are 3 occurrences of a and I already have a match. It's not going to consider this 4th a in the search. It will just look at the first 3 and it say, okay, there are 3 a's and my match is fine. So again, there are 2 matches in this case. Again, we're going to use the search function initially, and you can see in each of the cases there is a match except for the first case, which is this case. Now let's see the find all option and see what happens when we do the same thing using find all. So when we use find all, it basically gives us each of the instances where the match has occurred in each of these lists. Now let's try to use a slightly more complicated example, where we combine different, let's say, different meta characters, and we create a more sophisticated expression that we want to search in our test strings. So if you look at this expression, what we're looking for is 0-9. Now a dash symbol is valid in Python using regex, because what this basically tells it is that it's looking for either 0, 1, 2, 3, 4, so on until 9. Basically any of the digits. We're looking for any of the digits from 0 to 9, and we're going to check if at least 2 and at most 4 occurrences of digits, if they are there or not in our particular code. So let's see what are the matches that happens when we use it on test strings. So if you use it on this string, you can see it will find one match. This basically this particular part of the string where it says 1, 2, 3. So this is 3 occurrences of digits, so it's fine. Now when we look at this whole string, 12 and whatever this is, you will see this will not find a match here. This obviously will not, because these are characters. But if you look at over this part, it will find matches in terms of the first 4 and then 7 and 3, the next 2. 1 and 2 again, there are no matches because there's only single occurrences of digits. We're looking for at least 2 and at most 4. So if I use a find all, you will see like what all it will return. So for the first test string, what it's going to return me is, it's going to return me 1, 2 and 3, as you can see here. But now if you look at this test string, it's going to return me 12, it's going to return me 3, 4, 5 and 6, it's going to return me 3, 4, 1 and 2, but not 7, because we're looking for at least 2. And then it's going to return me 4, 5, 6 and 7, followed by 8 and 8, as you can see in this list over here. Now if we use curly braces with only one digit, it's basically telling the search engine that we want exactly so many repetitions of the preceding whatever expression that we have. So when we do this example, for example, we are basically saying that we want x followed by a dash, and the dash has to occur at least 3 times in our particular expression, and then it should be followed by an x again, which will not match in this case because there are only 2 dashes, and it will match in this case because there are exactly 3 dashes, and it will again not match in this case because there are 4 dashes. As you can see here, none followed by an object match followed by none. Next we move on to the alternation meta character. And as the word suggests, alternation is basically looking for some alternate form of A and B. So A should be followed by B, and basically this pattern has to keep going on. So in the first string over here, this pattern will not match. In the second string over here, we will have a match because we at least find an A, even though there is no B. But this is still considered a match because we did find an A at least. Over here we'll have 3 matches because we have A followed by a B followed by an A again. So if we did a regex expression for this, we would basically find these many matches for each of these examples. The next meta character is the group. Now a parenthesis is basically used to group subpatterns. So let's look at an example to understand what we mean. Now if you look at this complicated expression, what this means is that I want some form of x and z. The x and z have to occur together. But before that, what I want is some form of A following B following C. Some sort of alternation between A, B and C. So this part, as you can see here, is kept in a parenthesis because I want this whole condition to basically occur before I find an x and z. So let's look at what happens here. In the first case, we don't have a match because this parenthesis condition is not being met. X and z is preceded by a space, or basically the A and B is followed by a space. So if the space didn't occur, we would actually find a match, as you can see in the next example. Here you can see A and B occur. Basically this initial condition is met, followed by x and z. So there is one match. So it's fine for us. Now if you look at this slightly more trickier one, what you can see is we have 2 matches in this case. First an A followed by x and z, and then we have C, A and B. Now this is perfectly fine because we are looking for a B followed by an x and z. We're looking for either of these things. We're looking for some form of alternation of these things followed by an x and z. And we can get that over here. We get B followed by an x and z. So you'll get 2 matches in this case. Now let's go through the concept of grouping constructs. Now that you've seen many meta characters, you've seen how parenthesis works. Let's look at grouping constructs. So grouping constructs break up a regex in Python into sub-expressions or groups. And this serves 2 purposes. One is the grouping part, which basically says that a group represents a single syntactic entity. And any additional meta characters apply to the entire group as a unit. And then there's the capturing part, which basically tells us that some grouping constructs also capture the portion of the search string that matches the sub-expression in the group. And you can retrieve captured matches later through several different mechanisms. So let's look at basically what we mean by this example over here. So if you see this expression has a plus sign. So we're looking for, as you know, a plus looks for one or more occurrence. So this will basically check for one or more occurrence of the character R only, because there's no parenthesis as in this example. So this plus is next to an R, and it's going to check for basically whether one or more occurrence of R happens preceding B and A. But if we actually put B, A and R in a parenthesis followed by plus, it will actually check for the entire string BAR, and it will check one or more occurrences of BAR together. So if you look at these two examples, when we use this on these examples, you can see that these are fine, like these matches are fine. But if I used this parenthesis, then these would be the acceptable matches. And like BA triple R would not be a match if I use parenthesis, as you can see here. So this is how grouping constructs work and how parentheses work. So look at some other examples. So what this will do is FOO has to be optionally followed by BAR, and BAR must exist together. And this is because we have a question mark here. This question mark symbol tells us that there should be 0 or 1 occurrences. Similarly, this particular complicated expression is checking for one or more occurrences of whatever we saw earlier. Basically, this whole thing is followed by a plus. So we're looking for this whole sequence for one or more occurrences of it. COW is simply just COW. We're looking for this pattern. And this is going to check for 0 or 1 occurrence of COW because of the existence of the question mark preceded by the parenthesis. We're going to continue our discussion on regular expressions. Now that you know the basics of regular expressions, let's continue our discussion with special sequences. Now, in an earlier video on strings, you might have encountered what is an escape sequence and how we use the backslash character to generate these escape sequences. And an escape sequence is basically, if you remember, something that we use to either give a certain special meaning to characters that are otherwise ordinary, or it is used to remove the special meaning that are inherently present in certain characters that we call meta characters. So let's look at what special sequences are in relation to regular expressions. So the first one we're going to look at is the backslash capital A, which is used to match if specified characters are present at the start of a string. So out here, if you can see, we are checking if the word the is present in these two strings. So we would get a match in the first case over here because this starts with the word the, but in the second case we won't get a match. And this is how we're going to check it for the same thing using the findAll function. So if you see in the first case, it returns us an object because we do find the in the beginning of the string. In the second case, we get us empty list because this string does not start with the word the. Now the next one that we'll look at is backslash b, small b. Now this is used to match if specified characters are at the beginning or at the end of a word. So when you use backslash small b and then you follow it up with whatever you're looking for, it would look for those particular characters or that pattern if it exists in the beginning of a word in a string. So if you look at the first example, it starts with FOO. And in the second example, you see this portion of the string or this word is actually also starting with FOO. So it will also match. However, in this string, which is very similar to the second one, we don't have a space between A and F, and it's basically one word. So this does not start with FOO, but it actually starts with AFO, and it won't match, as you can see here. Now similarly, if we wanted to check if something exists in the back of a string, at the end of a string, we type what we want to search for first, and then we follow it with a backslash small b. And then if you see here, it will match in this first case, it will match in the second case because this part of the string ends with FOO, but it will not match in this case because, well, we removed the space, so now this whole thing becomes the string that we're looking for, and it does not end with FOO anymore. And this is basically us just checking it through the findAll function. Now the next special sequence that we will be looking at is the slash capital B, which is basically the opposite of what we just saw. This matches only if the specified characters are not at the beginning or the end of a word. So if you see here, this is checking if FOO is not at the beginning of these strings. So in this case, there will be a no match. In this case also, there will be a no match. And this third case, there will be a match. Similarly, if we wanted to see if something does not end with a particular string, we would type that whatever pattern we're looking for, followed by a \B. And then we can use the findAll function to generate us lists wherever we find such objects, find such matches in our particular test strings, like we have done over here. So the next one that we're going to look at is the \d. And this matches any decimal digit, which is equivalent to doing a square brackets 0-9. As you must have seen earlier. So if we did a square bracket 0-9 and if we did a search or a findAll or a match, it would look for any of the digits between 0 and 9. So a similar thing can be done using a special sequence \d. So as you can see, there will be 3 matches in this case because 1, 2 and 3 digits exist. Whereas in this case, for the word Python, there will be no matches. So these are certain examples where we are doing the same thing using the \d. Now we have another one, which is the \D, and this is just basically the opposite. It matches for any non-decimal digits. It's also equivalent to typing a caret inside square brackets with 0-9, which if you remember from the previous video, is basically asking us to check for anything that is not the digits 0 to 9. So this is basically, we're going to check in these two strings if there is no digits and no non-decimal digits. So if you see here, we will find 3 matches, A, B, and the double inverted commas. And in the second string, we will find no matches because this is fully just digits. Next, we have \s. Now this matches where a string contains any white space character. So this is equivalent to doing a check for all of these. So this is like \t is a check for tab space, \n is a check for break line, and then /r, /f, /v are their own checks for different sorts of white space characters that you can see by just looking it up, honestly. But yeah, so if you simply do a \s, it would actually be the equivalent of searching for any of these white space characters that we generate. So if you see here, when we do a \s on this string, you can see that there is one space over here. So it will give us one match because there is one white space, which is just the normal space here. And in the second example, there is no match because there is no white space here. Similarly, /S now, as you might have noticed, is basically checking for a string which does not matches in a string wherever there is no white space characters. So it's basically the same as doing caret /t, /n, /r, /f, /v in a square brackets. So this is basically a simpler way of doing the same thing using square brackets and a caret symbol. So if you see this expression, \S, now we're looking at A space B. So over here, if you see, it will match for all the non-spaces. So it's going to match for A and B. So we're going to get 2 matches here. Whereas an empty string does not contain, well, it does not contain any non-white space character, since an empty string is basically a white space character on its own. So this will give us a no match. So the next special sequence that we're going to look at is the \w. This matches any alphanumeric character, which is the equivalent of doing A to Z in small and then capital A to Z, and 0 to 9 and also an underscore check in square brackets. It's important to note that the underscore is considered an alphanumeric character, hence why we include it over here. But yeah, this is this \w, small w, which basically checks for any alphanumeric character and matches it in a string. So if you see in this first case, it will find 3 matches at 1, 2, and also at the letter C. These others are not alphanumeric characters. Whereas in this string, none of these are alphanumeric characters, so we will get no match. Again, much like the other examples, there's a \W, which will check for any non-alphanumeric character, and it's the equivalent of doing whatever we did before in the square brackets, just with preceded by a caret sign. So if you see here, we have this string where we have a bunch of characters. Well, yeah, only one of them, this percentage symbol, is a non-alphanumeric character. So we will get one match over here. But in this case, in this string Python, we will get no matches because they are all alphanumeric characters. We're just doing the same thing here with a bunch of different examples using the findAll function. Now the \Z matches if the specified characters are at the end of a string. Now don't confuse this with small b, because the small b checks for a string and it checks each and every word in the string individually and checks if any of the words ends with a particular thing or starts with a particular thing, but it checks each word individually. But in this case, the \Z will check the string only and not each word. So if you see the difference here, when you use capital Z, it will match in this first example, but it won't match for the next two. But if you used small b over here, it would actually match not only in the first example here, but it will also match in the second example, because it would check this word individually and it would find out that, yeah, there is a match here as well. So it would actually match in the second example as well. Now we will be covering the topic of serialization in Python. Now object serialization is very simply put, when we want to convert a data structure or an object type, and we want to translate this into a form that is that can be stored in a memory, such as a file or a memory buffer. Later we could deserialize this particular file and reconstruct the original object out of it. Now in Python, this is done. Object serialization is done by converting the state of any object into a byte stream. This byte stream can be further stored in any file-like object, such as a disk file or memory stream. It can also be transmitted via sockets. Deserialization, as I mentioned earlier, is the process of reconstructing the object from the byte stream. Now in Python, we refer to the serialization and deserialization by the terms pickling and unpickling. So the pickle module, which is a module that is a part of the standard library of Python, it provides functions for serialization, such as the dump and the dumps function, and also for deserialization with load and loads. The data format of pickle module is it's very Python specific, and so programs that are not written in Python may not be able to deserialize the pickle data properly. And it's also considered unsecure to unpickle data from unauthenticated sources. So in this example here, what I'm going to do is I'm going to take the dictionary object, which is represented by DCT, and its byte representation will be stored in a file called pickled.txt, and we will also gonna enable the write and binary mode preemptively. So if you can see here, first I'm importing the pickle package, and then I'm opening a file pickled.txt and write in binary mode. Then I create this dictionary, and I'm going to dump this dictionary into that particular file, and then I'm going to basically close the file. So this executing this would do this. Now it's important to note, a pickled file is not a human readable file. A computer can understand this, but it's so the byte representation of any object or data type cannot be read by a human in plain sight. So this next part is where I'm going to deserialize, or I'm going to unpickle the file pickle.txt. So again, I'm importing pickle. I'm opening this file in read in binary mode, and what I'm going to do is I'm going to load this into D. This will basically, in a way, deserialize whatever was there in pickle.txt. And once I have unloaded it in D, I'm going to print what's the content of D, which should be my original dictionary itself. So when I execute this, you can see that printing D prints my original dictionary that we had before. And it's important to note, since dictionaries are unordered, so dictionary objects don't retain the order of insertion of keys. So the way we enter the keys inside the dictionary when we create it is not maybe the same way that we will see the order of the key value pairs when we actually unload it. Now there exists a dumps function inside the pickle module that pickles Python data to a string representation. So we're going to do that in this next piece of code. So I'm importing the dumps function from the pickle module, and I have my same dictionary. What I'm going to do is I'm going to dump this dictionary into DCT string, and I'm going to print DCT string to show you like what exactly a string representation of this dictionary would typically look like. So when you execute this, you see this something very cryptic. So this is basically what we mean by the string representation. Of course, we can use the loads function again to unpickle whatever we just did and get the original dictionary representation of this particular string. So that's what we're doing in this piece of code. And as you can see, we get back our dictionary over here. So now in our second example, what we're going to do is we're going to create slightly more complex data structures, and we're going to do some serialization, deserialization on them. So we have this function called store data, where we initialize two dictionaries called Omkar and Jagdish with some certain key value pairs. Now we create another dictionary, empty dictionary called dv, which will be like a database. And now this dv has two keys again called Omkar and Jagdish once again. And now if you notice, my new keys are Omkar and Jagdish, but their values are these new dictionaries again. So we're basically storing a dictionary within a dictionary, so as to speak. So once we have done that, what we're going to do is we're going to create a another file called example pickle, and we're going to create it in binary mode. Now once we've done that, we're going to dump this dictionary db into this file called db file, where we have opened basically where we're going to store the serialized representation of this dictionary called db, and then we're going to close. So this is what store data will do when we call this function. And in load data, what we're going to do is we're going to print out what each key and what it represents. So we're going to basically deserialize in the load data function. We're going to deserialize whatever we just serialized in the previous function. So when we execute this, we should basically get something like Omkar followed by this sort of an arrow sign, and whatever the dictionary that we have assigned to Omkar is. Similarly for Jagdish as well. So when we do store data, it will basically do the serialization process. And when we do load data, it should do the deserialization and print out the the DB dictionary that we created in store data over here. So let's execute these two. Oops, I did not execute the load data. So now it should work. Yeah. So if you see now when I have executed load data, I get back. So basically from store data, I first serialized my whole file into a particular file called db file. And once I have done that, I have deserialized it using the load data function over here. Now we will be covering the topic of Python partial functions. Now partial functions allow us to fix a certain number of arguments for a function and generate a new function. The functools.partial module helps us achieve this. Now let's say we want to create a function that explicitly performs exponentiation. So we can get squares, cubes, and other power operations on any number. So let's look at an example. So we create this function called power, where we have a base and an exponent. So what this does is it will basically print some number which is the base to the power of some exponent, and the result which will be returned over here. So let's see now what if we want to create a dedicated square and cube functions that leverages this. So we can define a square function called with an argument called base, where we return the power of the same base to the power of 2. So we're defining a square function with the help of this function that we defined already called power. For cube, we will basically do the same power function, but the exponent will be 3. So now when we do square 10, we're going to say, if we executed all of this, so now if we say square 10, what this will do is it will say 10 to the power of 2 is 100. And if you see the next one, cube 5 to the power 3 should be 125, as you can see here. Now this works, but what if we want to create say 15 to 20 variations of our power functions, and what about say 1000s of them? Defining a function for each case is obviously very repetitive, it's annoying, and this is where we will find partial coming into play. So as an example, let's do the same thing. Now what we're going to do is we're going to import partial from the module called functools. We have what we're going to define is this function called square, which is basically going to use the partial functions operation for the power function with the exponent of 2. So what we're doing is basically we're going to use the power. We're going to reference the power function that we defined earlier, but we're going to pass the argument for exponent as 2. And for cube, we're going to do the same thing, but exponent is 3. So once you've defined this, if we do square 2, you get the result as you can see. For cube 2, you get the result as you can see here. Let's look at another example. So we have this function where we define some function with 4 arguments. Now what we're going to do is argument a, b, c, and x, right? So we're going to return 1000 times a, 100 times plus 100 times b, plus 10 times c, plus x. Now we're going to create a partial function that calls this function, but it's going to use a as 3, b as 1, and c as 4 always, right? And so how we do that is basically g is equal to partial like this. So once we've executed these, now if we say g10, we basically get the value for 1000 times 3, since a is 3, plus 100 times b as 1, so 100 times 1, plus 10 times, well, c is 4, so 10 times 4, plus x. Now x we passed is 10. So the result of all this will be 3150 as you can see here. Now let's look at the final example where I've defined some function called add. I have 3 arguments a, b and c. What I return from this add function is 100 times a plus 10 times b plus c. So let's create a partial using partial functions where b is 1 and c is 2. So we have this fixed. We can create a partial function called add part. So what this does is it takes the add function, it creates a partial function out of it using c is equal to 2 and b is equal to 1. So now when I print add part 3, what happens here is 3 gets passed in the form of a. So I get 3 times 100, and since b is fixed as 1 and c is 2, so I get 3 times 100 plus 1 times 10 plus 2. So it should give me 312. So when I execute this, you can see this here. Now we will be covering the topic of closures. Now before we understand what a closure is, we have to understand what is a nested function and non-local variables. Now a function which is inside another function is known as a nested function. Nested functions are able to access variables of the enclosing scope. So if I define this function called outer function, where I pass some argument called text and I store that in a variable called text again, and if I create a function within this called inner function, and I want to print whatever this variable is in text, when I execute this, it will be able to access this variable because it's within the enclosing scope. So if I said outer function hey, this gets stored in the variable text, and then the inner function will print that variable, which is basically the string hey, as you can see here. Now inner function can easily be accessed inside the outer function body but not outside of its body. So here inner function is treated as a nested function which uses text, this variable text, as the non-local variable. Now a closure is a function object that remembers values in enclosing scopes even if they are not present in memory. It is a record that stores a function together with an environment. It's a mapping basically that associates each free variable of the function, which are basically variables that are used locally but are defined in an enclosing scope, with the value or reference to which the name was bound when the closure was created. A closure which unlike a plain function allows the function to access those captured variables through the closure's copies of their values or references, even when the function is invoked outside the scope. So let's look at an example to emphasize on what was just said. So again, I've defined this function outer function where I'm doing the same thing. Now I've defined the same inner function where I'm going to print the same thing. Now it's very important that when I return over here, what I'm going to return is inner function, but it's not going to be a function call. This is important to create our closure. So we return inner function but without using the call as we do over here. And what this return will do is basically to create the closure where the inner function will remember the values of the variables stored in the enclosing scope. So now I'm going to store this outer function in an object called in a variable called my function. Now when I call this my function, you can see there'll be two things that are happening here. So once I've defined this and I've executed this, what happens out here is this function has already executed and then I'm storing it to this. But because I've done return inner function without parentheses, I've created a closure basically. And this closure allows the inner function to remember the values that were stored in text at any point and at every point, even after the execution of this one time. So when I execute this again for the second time over here, it will remember the value that was stored in the variable text, which is hey, which was given over here. That's why you see when I execute it for the second time over here, the first time being in this line when I'm storing it in my function, when I execute it the second time, again it will give me the result of hey. As you can see, the closures have to invoke functions outside the scope. The inner function has a scope only inside the outer function, but with the use of closures, we can extend its scope to invoke a function outside the scope. So now let's look at this code. So this code, don't worry about what's going on here. Just know that what we are doing here is we have two functions which we defined called add x and y, which will return x plus y, and the subtract function, which will subtract x and y. So now we're going to execute these. Once we're going to execute the add over here and add logger, and we're going to execute the subtract function, and we're going to store it in sublogger. So technically we have already executed these two functions, but now since I've created an enclosure, basically if you see here, this is the enclosure that I have created. Now what happens is when I access this function from outside its initial scope, which is basically over here. This was the initial scope. When I access it outside, you will see that it still has access to these variables x and y. So if you see here, I first of all I've allowed the enclosing function to accept arguments of any numbers. So I can pass xy, I can pass xyz also. But if you see here, I only have a thing for x and y. So when I want to access any value of x and y, even after the execution of this code initially, I have access to these variables x and y, and that is because I've created a closure out of that. So if you see, if I do add logger 3 and 3 over here, I'm able to get the result 6. If I do add logger 4 and 5, I'm able to get the result 9. Similarly, for subtraction logger 10 and 5, I will get 5 here, and 20 and 10, I'll get 10 here. And I can keep doing this. I can keep saying add logger, and if I say 4 and 7, so if I executed this, and now I'm going to say, let's say for example, add logger, if I said 4 and 7 here. So this still has access to my variables x and y because I've created the closure, and it should give me 11. Similarly, if I did sublogger, say 30 and 15, it should give me 15 because 30 minus 15. So let's say 30 minus 16, right? So it should give me 14 because again, I have created the closure and it has access to these variables already. Now we are going to be learning about the topic of decorators. So to start off with, let's first understand some basic concepts. Now in Python, we know that functions are first-class objects, and that means that functions are objects and they can be referenced to, and they can be passed to a variable, and they can be returned from other functions as well. Functions can also be defined in another function and can be passed as an argument to other functions. So decorators allow programmers to modify the behavior of a function or class. Decorators allow us to wrap another function in order to extend the behavior of the wrapped function without permanently modifying it. Now, any generic functionality that you can tack on to an existing class or function's behavior makes a great use case for decoration. Some of these include rate limiting, caching, logging, enforcing access control and authentication, instrumentation, and timing functions. Now you have to remember that function names are references to functions and that we can assign multiple names to the same function. So for example, if you see here, I have defined a function called success, which does basically you pass an integer and it returns 1 plus that integer. So if I do success 10, it should give me 11, as you can see here. Now if I'm gonna say successor is equal to success, I've basically created another function called successor, which does the same job as the success function. So now if I pass 20 to successor, it should return 21, as you can see here. So as you can see that we have two names, success and successor, for the same function. An important fact is that we can delete either any of the functions, and you won't delete the other one. So if I said delete success, and if I tried to pass 10 to the other function called successor, it would still execute the whatever task the function is supposed to do. Now let's look at an example of a function inside a function. So I've defined a function called f, in which I have defined another function called g, which has two print statements that you can see here. The function f itself has two print statements, and at the end of the execution of function f, we call this function g. So let's see what happens when we actually execute f. So let's look at it on this side. So if you see here, this is where I've defined it. Now let's call my function f and let's see what happens. As you can see, first when you execute function f, it will create this function, and then it will print these functions, and then it will do a call to this. And when we call this function g, it's going to do two of its own print statements, as you can see in this order over here. So this is an example of a function within another function. Let's look at another example of something similar. If you see here, I've defined a function called temperature, where I can pass some value for T, and I have defined another function within this called Celsius to Fahrenheit, and basically I'm doing the conversion. So when I execute this, what it should return me is I'll pass some temperature, and it will return me the temperature in degrees. So for example, in this case, I have passed temperature 20. So let's see what does it pass, what result does it give to me in degrees. As you can see, it says it's 68 degrees. Now let's look at another example of a function within a function, for a very common example for the factorial function. So if you see here, I've defined factorial n, and I'm saying if the value that is passed in n is equal to 0, return me 1. Otherwise, return me the product of that number times, and I'm going to do a recursive call back to the same function, except now I'm not going to pass n but n minus 1. So what this should do is, if I pass 10, for example, it will basically check, okay, since 10 is not equal to 0, it will go here, and it will return me 10 times factorial of 9, and that will do 10 times 9 times 8, and then so on until we reach n is equal to 0, where it will just say, okay, return 1. So what you will effectively get is 10 times 9 times 8 times 7, so on until 1, which is basically factorial of whatever we have passed. So let's execute this. See, I'm going to check what is the factorial of 5 here, and as you can see, it gives me 120. Now let's include a line, let's raise an exception by an else statement, which will basically raise a type error, and it will tell me that if I pass a number n which is not an int, and if it's not greater than or equal to 0, it should give me this error message. So I have included this extra statement in this just to check. So if I pass 9, as you can see, it should give me a valid result, which is 362,880. Now what if I pass minus 5? So let's execute this. As you can see, I get the type error that I have raised over here in case I meet such a condition. And in this case, you cannot find the factorial of a negative integer. So that is why my type error gets raised over here. If you actually look closely at this program, you will notice that each time I call back my function factorial, so if I gave it 5 initially, it will check for the this condition, and since it will meet the condition, we can continue. But the next time when we call factorial for 4 and then for 3 and 2, each time is going to do this check. That's kind of redundant, because we know that if we passed 5 in the beginning, until we decrement it to 0, we're going to only get the valid numbers 5, 4, 3, 2 and 1. So we don't need to do this check at every point. We just need to do one check. So a workaround for this would be in this code that I've written over here. And in this, I've basically defined a factorial function called n, where I'll pass my integer initially. And within that, I've defined the actual function where the actual results will be calculated, and that's called inner factorial. This is where this is basically the actual factorial calculating part. And if you see this if statement block, this is my check. So this will basically be the only check that will happen. So out here, it will check whether the n I have passed is a valid integer and equal to or greater than 0. And if it is, then we will perform this inner factorial function, where we won't be doing any more such checks. We will only calculate the factorial. And if it's not, then we will raise this exception just once, and we will exit the program in case we've given a wrong number. So let's look at an example for 3. So as you can see, at each step of my calculations, I'm going to return whatever value I have at that point. So basically, if I give 3, you will notice that you will get 0, 1, 2 and 6 if you multiply it in the right way. So let's do this. As you can see, factorial 3. 1 second. So I have to execute this. Now if I execute this, you can see I first get, because initially it will check, when I move into inner factorial, it will check if n is equal to 0. It will basically return whatever value I have at that point. So basically this is the order of calculations in a backward way. So you can see here it will first be 1, and then 1 times 2, and then 2 times 3, which is 6, which is what we get. So don't worry about the order in which we are returning these values. This is basically just a reverse way in which the program will fetch our values. So yeah, this was basically how we reduce the redundancy in the check part of our function. Now let's look at some examples where a function will be returning another function. So as we know, the output of a function is also a reference to an object, and therefore functions can return references to function objects. So out here, if you see, I've defined a function called f, which will take a parameter called x, and then within it I've defined a function called g, which will have a parameter called y. And this g will basically return y plus x plus 3, and the function f itself will return the function g. So if I pass 10 in function, so what this will do is it will create a function called g. I will create an instance of a function called g, and that object is going to be returned to us because we basically return g when we call function x, right? So if I execute this, you will see that when I say f10, it will give me some object location of a function called g. Now if I want to see the result of what I get for this function g, I have to pass something within g itself. So out here what I'm going to do is I'm going to store this function object in a variable called nf1. Once I've done that, I can pass another parameter for this nf1 object. And since we know this nf1 is a variable name for the function g, so when I pass nf1 20, I'm basically passing this y parameter. So since now I have passed 10 for x and I have passed 20 for y, oops, 1 second, yeah. So what I will get returned is 20 plus 10 plus 3, which is 33. When I do nf1 and I pass 20 as the parameter here, as you can see, I get 33 over here. Now let's look at a function where we will implement polynomials of degree 2, and then we will actually extend that to polynomials of any degree. So I have created a function called polynomial creator, where I pass 3 arguments which will represent the coefficients. So a will represent the x squared coefficient, b will represent the x coefficient, and c the constant. So I have defined within this, I've defined a polynomial function called x, where I will pass my value for the variable x, and I want to get returned the value for this polynomial. So as you can see here, initially the first function will return this object, and then for this object itself I will have to pass another argument where I'll pass the value of x. So I'm going to create 2 instances of this polynomial function. In the first instance, my coefficients are, as you can see, 2, 3, and -1. In the second case, it'll be -1, 2, and 1. So once I execute this, oops, let me execute the function initially. Yeah, there you go. So if I execute p1, it will basically give me a object location of the polynomial function for p1, which is represented by this basically. So now what I'm going to do is I'm going to iterate through values between -2 and 2, not including 2, at steps of 1. So I'm going to iterate for -2, -1, 0, and 1. And I'm going to say, initially print me the values of x that I'm going to pass in this column, this first column. And then I'm going to say, okay, what are the results for the first polynomial object where the coefficients are 2, 3, and -1. And then in this column, give me the values of the polynomial with these coefficients, -1, 2, and 1. So when I execute this, as you can see, these are my results. Now, what if I wanted to do the same thing for arbitrary coefficients, as in a polynomial of nth degree? I'm not specifying the exact degree. So this I can do with this slightly more complicated program, which is actually very simple. So if you see this function, I have defined a polynomial creator function again, but in this case I have passed variable number of arguments. So this asterisk basically means I can have any number of arguments here, and this will be an iterable with any n number of objects that can be iterated upon. So and that will be called coefficients. So within that, again, I've defined polynomial x. Now what I've done is I've initialized some variable called res, which will basically be my result variable. And what I'm going to do is I'm going to for loop through this coefficients iterable. And what this basically does is, in a backward way, this is basically going to iterate through the array or the list or whatever we have of coefficients in a backward way. So if I pass 6, 7, 8, 9, it's going to give me 9, 8, 7, 6 in that order. And what this enumerate function will do is it will assign an index to each of the values and coefficients. So for example, I can just show you over here what this means. So if I created a array called say coefficients with some random values over here, right? Now if I'm going to perform this line, right? Now let's see what happens when we do a for loop. Let's see what values we get for index and when we do this, execute this line. So if you see here, once I execute this, as you can see, what I have done is coefficients. Oh, I made a spelling mistake. This is taking from a different variable. So let's fix this. So as you can see, I've entered 4 objects, 4 integers, 1, 23, 4, and 45. And when I do this for loop, I basically want to assign some index value 0, 1, 2, and 3 to each value in this list, but in a backwards manner. So this will be the 0th item, this will be the first, this will be the second, this will be the third. So that's what we are doing in this function as well out here. We are basically going to use this enumerate function to, now if you see this result is basically going to add each component of this polynomial. So if you see closely, what this is going to do is it's going to first in the first step is going to find out, well, what is the value of this, the constant term. And then in the next step is going to find out what is the value of this. And it's going to keep summing it up. It's going to sum this part up until the end. And then we will get our final result in this variable res, and we're going to return that over here. So if you see here, I've done the same thing. I've created 4 function objects, and they're called P1, P2, P3, P4. And now I'm going to iterate through again -2, -1, 0, and 1 as my different x values, and I'm going to see what are the different values for each of these polynomials. So if you see here, my first polynomial is basically, it has only one coefficient, so it's a polynomial of the 0th degree. So basically whatever I pass for x, that itself should be my result. So actually this is a polynomial of 0th degree, so this is basically the only result we will get. So the constant is 4, we will get 4 in every result. So if you see here, what I'm printing is the x values first, and what are their respective polynomial values for each of these objects that we've created. So this is a constant, so P1 will only have the result 4. This is P2, so this is a polynomial of degree 1. So it's like saying 2x plus 4, and where x takes values -2, -1, 0, and 1. And in this case, you can see this is a polynomial of 4th degree. So it's like saying x to the power 4 plus 8x cubed minus x squared plus 3x plus 2. So when we replace x with -2, -1, 0, and 1, we get the respective values in the P3 column over here. And for P4, it's basically a square polynomial. So yeah, this is an example of how we can create, we can do a polynomial creator and get our results accordingly. Now, interestingly enough, what we've done here is basically, like, for example, let's look at P3, right? P3 is basically this polynomial. Now, this polynomial function inside our decorator, polynomial creator. So all these examples that I've been showing you where functions are within functions, if you think of it, it's like I'm giving some basic function extra, like I'm doing something extra within them, right? So we can use decorators for this. And in our example over here, what I can do with this function is I can implement the same operation more efficiently by using a decorator within our main function. So we can factorize it in a way that it does not need any exponentiation. So we can, if you think of it, this polynomial can be represented like this, right? If you think of it, it's basically this times x plus some constant, and then that whole thing is again times x plus some constant. Since this is to the power 4, this is all we need. But if you think of it, if we keep going further, all you have to do is again enclose it in another bracket and then do times x. So we can basically use a decorator to do this function. So if you look at this function over here, what I've done is I've created the same polynomial creator with variable number of arguments. But inside this function, like what I've done in the form of a decorator is that I'm going to implement this polynomial by calculating the result in this manner, where it's going to be very much more efficient, and you don't have to keep exponentiating like how I did in this example. So that's what I'm doing over here. And if you see, that is basically implemented over here through this. So when I do the same, when I execute the same thing, and if I go through the for loop again, it should give me the same results, but it's much more efficient. Now let's look at another example of a simple decorator. So we have I've defined a function called our decorator func. Now this will basically be, this is a reference to another function itself, if you see within this. But inside my decorator, I have a function wrapper where I'm going to print this statement before actually like calling the function x, before calling the function. And I'm going to perform a print statement again after that. And I'm going to return the function wrapper at the end of like executing the decorator. So let's look at what happens when we define this function foo_x. So this is basically a simple print statement where I'm saying, hi, foo has been called with whatever this is, argument. So now let's execute what happens when I say foo hi. So as you can see, let's execute the whole thing. So yeah, as you can see here, I have executed this. It says this is the print statement that I've basically written over here, and this is what gets printed when I call this function here. Now when I move on to the next statement, what I'm declaring is I'm going to now decorate foo with f. Now what this means is I've now created this this decorator object basically. So let's look at what happens when I execute this, and then I'll try to explain to you. So when I execute the whole thing, you can see something else is happening now. So we call foo after decoration. Then we have this before calling foo, and this is basically this print function. This is the print function that gets executed here. Now we have this. This is the function call. This is basically the function call, which is basically this foo function. And this line is being printed from this. So if you see here, I'm getting some results from this, like from this decorator itself, but I'm also calling upon the function that is being referred to by this decorator. So I'm doing two things. I'm doing the main thing, which is being executed here, which is the result is here, but I'm also decorating it with these two lines, which comes from this decorator called our decorator. So let's look at the explanation. So if you look at the output of this previous program, we can see what's going on, and that is that the decoration foo, this when we did this line, which was over here, it's a reference to the function wrapper, which is this. Now in this function wrapper, this function itself, right, like this function that we defined here, that will be called as well, but we will also have a bunch of extra like print statements in the form of these two lines, which you can see over here, before calling and after calling, that we've also done along with this. So this is a simple example of how we've used a decorator to modify our basic function. Now this usual syntax for decorators in Python is with the at symbol. So we can write the same thing like what we did before through this. So we write at our decorator, and this will basically apply the decorator to this function foox. So when we do at our decorator and then we define this function and we call it, it will basically do the same thing as doing this, for example. So if I execute this, you can see the same thing has happened here. Now I'm going to give you another example of a decorator. Remember the factorial function that we did earlier, where we did a check within the factorial function. Well, let's see how we can use decorators to aid our case in this. So as we know, before we calculate the factorial of something, we want to make sure that whatever we pass is greater than or equal to 0 and it's an integer, right? So let's define a decorator which will basically do this. So in this decorator, what we're going to do is we're going to create a function called helper, where we're going to perform this check, and this is going to be our decorator basically, right? However, so what this will do is basically this decorator will say, okay, if this check is met, then you can return the value of function of x, which is the function is what we pass in this as an argument to the decorator. So once the check is done, we can perform a factorial. So that's what we're going to do here. So we've defined our decorator. Now we're going to use the decorator here, and we're going to define within it a factorial function. So when we actually perform the factorial, like for some numbers, like we're going to do factorial of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all these 10 digits from 1 to 9, sorry. So if you're going to do that, what it's going to do is at each step, so for the value 1, it's going to first check whether our integer passed is actually the correct form of an integer, whether it's an integer and greater than or equal to 0. So once that is done, then it will move on to the actual factorial function. So when we do for I in range 1 and 10, since every number is valid, we won't get nothing wrong will happen. There won't be any exception raised. But what if we did factorial -1 now? Now the factorial function itself doesn't have a check, but since we have a decorator around this factorial function, it's first going to do this check, and if it finds an error, it will raise an exception. So if I do this, if you see when I execute, it raises my exception. So this is how we have added some functionality to the original factorial function using this decorator. Now we will be covering the topics of map, filter, and reduce functions in Python. Now Python provides several functions that enable functional approach to programming. And since functional programming is all about expressions, some of these expression-oriented functions of Python are lambda functions, list comprehensions, map, filter, and reduce. Now we've already covered the topic of lambda and list comprehensions. Now let's cover the topics of map, filter, and reduce. So to start off, let's look at the map function. The map function takes in two attributes, a function and a sequence. A function is basically some user-defined function or any function. A sequence is basically an iterable object like a list or a tuple, for example, or a bunch of lists and tuples as well. So let's look at an example. So one of the most common operations that we do with something like a list is doing an operation on each of the elements in the list and then outputting a new list with the values as whatever we have modified to the original items of the list. So what if we did the square of all of these items in this list, and we want to create a list based on that. So we can basically iterate through it, and we can do a square function and then append those values to a new list called squared. And when we do this, for example, over here, you can see when we print squared, we should get the list of whatever square values we have for the original list. But this is slightly a bit tedious. And what if we had a method what if we had a technique wherein we could basically pass a function that we have that we want to do and a sequence on which we want to apply this, and we pass it to a function, and this function basically takes care of applying whatever operations we want to do on each element of a sequence. So this is where the map function comes in use. So let's look at how we use the map function over here. So if you look at this, I've defined a square function. So the square function basically returns, takes an argument x and returns the square of it. And I have a map function which takes the square function as one of the arguments, and the list or an iterable as the second argument. So this map function creates a map object, if you see here. So let's just do it one by one. So I'm creating my list, and I'm going to create my function called square, and I'm going to send this to the map function. So I'm sending this the first argument as the function that I want to do, and the second argument as the list that I want to apply it on. Now let's list out all the items that are in this map object. So if you see, it creates me a list with basically the squared items, and this is exactly what we needed. And another way of doing the same thing would be just going through a for loop in each of the map objects and printing each, which would give me the same results. So if you see here, I found a very neat way of passing a function and an iterable, and using the map function to apply each operation that is part of the function, or applying the function on each item in the iterable. So as you've seen, we basically passed in a user-defined function, and we applied it to each item in the list. Then the map calls the square function on each list item and collects all the return values into a new list. And because map expects a function to be passed in, it also happens to be one of the places where lambda functions are appearing a lot. So let's look at an example where we do the same operation using a lambda function. So if you see here, I have a lambda function where I'm passing it as the function argument, and what this lambda function takes is some variable x or some argument x, it does its square and it returns that x. And this x is basically going to come from each element that is present in this list called items. And when we list down these, you will see it basically does the same thing for us. It creates a list with squared items. Now we can also pass, instead of passing an iterable itself, we can actually pass a sequence of functions and use the lambda function to perform a sequence of functions on particular items. So let's look at a new example, a slightly different one. So we're going to use a numpy module for this. Don't worry, we're just using it to use the square root function that is present in the numpy module. We will be learning about numpy in a later section. So we're going to import this first. And now I'm going to define three functions called square, cube, and square root. So once I've defined these, basically they're returning the square, the cube root, the cube, and the square root of some integer x. And now I'm going to create a list of these functions that you've just seen. And we're going to use a for loop, and we're going to iterate through a range from 0 to 4. So, and we're going to pass this, and we're going to say that we want to apply some function. We want to apply some function x, and we want to return that using this lambda function. Now what values this x will take is based on whatever functions we've stored in this variable called funcs or funcs. And in funcs, we have a bunch of functions called square, cube, and square root that we have defined earlier. So what we're going to do is we're going to apply each of these functions to R, and R will take the values 0 to 4. And now let's see when we print this, what values we get. So if you see here, we get a list of squares, cubes, and square roots for integers 0, 1, 2, 3, and 4. So this is another way of using the map function and lambda functions together to apply multiple different operations to a bunch of iterables. Now for our next example, what we're going to do is we're going to create a function that basically what it does is it creates the uppercase of some string that we pass to it, right? So that's what we've done here in this function called toUpperCase. So let's first define this function. Now we have a print function basically, which is going to print each object in a particular, which is going to print each element of a particular object, and is going to, at the end of it, and the end of printing, we're going to give a small space for printing a new line basically. So let's create this also, this print iterator object. Now what we're going to do is we're going to pass a string with the letters A, B, and C to this function, and we're going to map, we're going to apply the uppercase function to this string. Now if you remember, string is also an iterable, where it's a sequence of one character strings. So this whole string is basically a sequence of one character string A, one character string B, and C. So we're going to, we can pass a string as an iterable to the map function because it will apply the operations on each of these characters. So let's see what happens when we do the uppercase function. We apply the uppercase function using the mapping to this string A, B, and C. So if you see, it's created me a list with capital A, capital B, and capital C, as we had expected, because we have applied the list function to the map object. Now, in the next step, what we're going to do is, we're going to do a very similar thing. We're just going to, instead of simply mapping and creating a list out of it, we're going to store the map object in a variable called map iterator. We're going to print what type of object it is, and then we're going to print out each of the elements using the print iterator function that we defined here. So let's do this. Now if you see, the class, the type of object is of class map, and the objects, elements inside the object are A, B, and C. Moving on, let's look at now an example where we're going to pass multiple arguments. So instead of one iterable, we're going to pass multiple iterables now, and we're going to apply some sort of an operation. So if you see here, what we have done is we've created two sequences. One is a list of some numbers, and another is a tuple of some numbers. So just to show you, let me first copy this here. Yeah. So if you see here, I have a list and a tuple, and I'm passing both of these, if you see, to this map function. And before that, I have defined a lambda function as the operation that I'm going to apply. And what this does is it takes two arguments, x and y, and it returns the product of both of these. Where does it get x and y from? So the x it gets from this sequence, which is a list, and it takes y from this sequence, which is a tuple. So what it's going to do is going to take x as 1 and then y as 5 in the first step, and it's going to return the product as 5. And then the next step is going to take 2 as x and then y as 6, and it's going to return the product of that, and we're going to get 12, and so on. We're going to get 21 and then 32. These values are going to be stored in the map iterator, which is a map type object. And when we use the print iterator function, it's basically going to print out whatever results we got through this mapping. So let's execute this, and as you can see, this is the result we got: 5, 12, 21, and 32, which is what we wanted. So the next part, the next function that we're going to discuss is the filter function now. Now a filter function is basically, again, it takes two arguments, a function and a sequence, and a function basically tests if each element of a sequence is true or not. Now so this filter function will basically take two arguments. So one is the function, and this function is basically going to test if each element of a sequence is true or not, and it's going to take another argument called sequence. And this argument sequence is the list or the tuple or basically any sequence or iterable that needs to be filtered. And it can be, as I mentioned, it can be sets, lists, tuples, or containers of more iterators. And what this function will return is an iterator that is already filtered. So let's look at an example now. So we have this list R, which we've generated, which is basically numbers from -5 to 4. So if I create this list here, you can see it will create a list of -5 to 4. Now, if I wanted to extract only the values that are lesser than 0, well, I can use a for loop and use a if condition to check this, right? So if I did this over here, you can see it returns me some list called result, which contains only the values lesser than 0, which is basically checked through this condition. What if there was a neat or a more convenient or a more organized approach to doing the same thing? Instead of creating a loop ourselves, what if we defined a function where we are going to do the test, or we're going to create the condition, and we're going to pass this to a particular function and then apply that particular operation on every object of some sequence? Well, just like mapping, we have a filter function to do this. And in this example, what we're going to use is the lambda function, which takes an argument x, and it checks for some condition x lesser than 0. And where it's going to get the x from is some sequence R, which in our case is the numbers from -5 to 4. And the filter will basically create a filter object type which contains only the objects from R that meet this condition, that is x is lesser than 0. And when we use the list operation on top of it, you will see it results in a list with the values that have met my condition. So for our second example, what we're going to do is we're going to create a list which contains a bunch of letters, and we're going to only extract the vowels from these bunch of letters. So let's look at what we have here. We have some letters D, A, T, J, K, O, P, L, and we only want the vowels from this. So we want to filter only the vowels. So we can use that using the filter function by first of all defining a function that returns true if a check is met that one of the letter matches one of these letters in this list called letters. And if it doesn't, it returns false. So this is our condition that we've created. Once we create this condition, this function that checks this, we can pass this function and the sequence into the filter function, and then we can list out whatever we get. So you can see our filtered list contains only A and O, which is basically the only vowels that are present in our original list. Finally, we have the reduce function. This reduce function is basically a functools. It's in the functools module of Python 3.0. And what the reduce function does is it applies a function of 2 arguments cumulatively to the elements of an iterable, and it starts with an initial argument, and it returns a single result. So let's first import this function. And once we've imported it, let's use it in this example that we have here. So in this example, what we're going to do is we have some list called numbers, right? What if we wanted to get the sum of each element in this list? Well, we can iterate over it and store it in some variable called total in each step, right? This is what we would typically do. And in this step, what you can see is the loop basically iterates over every variable in numbers and accumulates them in total. The final result is the sum of all the values, which is the value of 10 over here. In this example, the variable total is what we call an accumulator, and we can apply the reduce function to do the same task. So how do we do it? Let's first of all create a function called myAdd, where we're going to take 2 variables, 2 arguments, and we're going to return the sum of it. Okay, so let's define this function, and now we have a list called numbers, right, which contains 1, 2, 3, and 4. Now let's do reduce myAdd to numbers. Now when I use this function, what it will do is it will apply the function of myAdd. It will take basically each and every element in a sequence. So it will take 1 and 2, then add them together, and then it will create, basically what it will do is it will take 1 and 2, add them together, then we will have 3. So it will take 3 and then the next element, which is 3 again. So it will create the sum, which is 6, and then it will take 6, and then it will take the value 4, and it will give us the result 10. So this is how the reduce function would work. So this is how it will give us the result of 10. As you can see here, I've passed this function where I've defined that I want 2 arguments to be passed to a function, and then the return should be basically the sum. And then I've passed a whole list of like 4 numbers, and I've used the reduce function to basically do this process for 4 numbers in a step-by-step manner by taking 2 at a time subsequently. And my result, as you can see, is correct, as you can see here. So let's use the lambda function now to do the same task. So what I'm doing now is I'm going to define a lambda function, and that's the function I'm going to pass to this reduce. So when I pass this lambda function, which basically takes 2 arguments, x and y, and it's going to return the sum of that as x plus y. Now where it's going to get x and y from is in a very neat manner. So it will take first the first 2 elements, 1 and 2. It will then do the sum, and we get 3. Then it will take that same 3 and then take the next object, which is 3 again, and then give us 6. Then it will take 6 and then the next element, which is 4, and then give us 10. And then the reduce function will output the single result, which is 10 to us, as you can see here. Now we will be learning about the concept of lambda functions. Now a lambda function in Python is an anonymous function without a name. We usually use lambda functions whenever we want to create a function type object for a short period of time. A lambda function is defined using the lambda keyword. Like a normal function is defined using the def keyword, we define a lambda function using the lambda keyword. Also, the lambda function can take any number of arguments, but it can only accept one expression as a part of it. So think of a lambda function like a sort of a temporary function object that you create whenever you want to perform a particular task or object, but you don't want to give it a name, or you don't want to define a full-blown function and give it a name like that. So over here, I'm going to give you an example of a lambda function. Let's say that this lambda function takes in, let's call it x. And so you define the function, let's call it x. Let's call it a lambda function using this keyword. Now we want, say, two parameters, right? We're saying, say, a and b, or two arguments, a and b. So we're going to pass two arguments, a and b, whenever we use this function. And we're going to perform some sort of an expression. Now let's write down a simple arithmetic expression for this. Once you've defined your arguments, just use the colon. Now over here we have our expression. So let's call it a plus b. So now we've created a lambda function called x, where we will pass two arguments, and the result will be the expression a plus b. A and b being the arguments we pass. So now let's print the result of let's say we pass 1 and 3. So now we should get the result 4, right? Because a plus b is equal to 4. So we've passed a as 1, b as 3. Now let's execute this. As you can see, the result is 4. Similarly, you can pass any number of arguments. So we want to call some function x, let's say lambda function. Maybe say a, b and c this time. And we want to do the product of these three arguments. So now when we do, when we check the result, let's say we're doing the product of 2, 4 and 6. So this should be 48. And when you execute this, you get 48, as you can see here. So these are two simple examples of a lambda function. Now I could have done this in a different way, where I could have defined some function x, and over here I defined that it takes in 3 parameters, and then you can define some, say, return. The function basically returns you a, product b, product c. But many a times you don't need to define a full function called x. You don't want to assign some function with this name. You just want to create a temporary or a short time anonymous function with some name just to perform a simple expression. And in that case, we can use lambda functions. That's an example, by the way. You can use lambda functions in multiple places. So let's move on now. Now, for the sake of this video, what I'm going to do is I'm going to show you how the sorted function works, and we're going to learn how the lambda function uses this sorted function, how they work together. So this will give you a clearer understanding of how we use the lambda function in our code. So to start off, sorted function returns a sorted list from the items in an interval. So you can have a bunch of, for example, numbers, and the sorted function by default will give you, will return you the list of numbers in an ascending order. Of course, you can also, using a parameter called reverse, you can return a list of numbers in the descending order. You can also do this for strings, characters. So if you give it a bunch of characters, say A, E, F, G in the alphabet, it will give you, if you use a sorted function, it will give you the characters. It will return it in an ascending or descending order depending on the parameter you give. So basically this the sorted function, the syntax is you use the keyword sorted, then you pass the iterable, which is basically some list or some tuple. Then you give it a key. So this key sometimes we don't need to give by default. If the iterable does not contain multiple items per object, for like if it's not a tuple of multiple objects, if it's not a list of tuples, for example, you don't need to give it a key. If it's a simple list of numbers, you don't necessarily need to give a key if you want to sort it. But yeah, a key is basically the parameter which we use to tell the sorted function that we want to sort based on something, which is going to be the key in this case. Finally, the third parameter is reverse, which basically just tells us that if we want to sort in the default ascending order, or if we say reverse true, then we will sort in the descending order. Now, let's look at some examples. So I have this list over here, and I'm going to print this list. So this list is obviously a bunch of vowels, E, A, U, O, I, and this is not in the ascending order of the alphabet, right? Like we know it as A, E, I, O, U. If I print the sorted form of this list, it should give me A, E, I, O, U, a list with A, E, I, O in the ascending order. Sorry, yeah. So now as you can see, it's given me this list as you can see here. Similarly, if I gave it a string as you know is an iterable. It's a collection of characters. So if I use a sorted function on this, interestingly, it will give me a list of these individual characters like P, Y, T, H, O, and N, but in the order that we want it to be in, which is the ascending order, of course. So if I print this, you can see it returns me the list with each character in the order that we wanted it to be in. Now you might notice, why does P come before H? That's because this is in uppercase. So what this does is, first it sorts all the uppercase characters, since there's only one, so it just places it in the first object of this list, and then it sorts all the lowercase characters that you see here. So yeah, moving on now. Now what if we wanted to say sort this in descending order? So we have this list, and now we want to sort this in a descending order. So in that case, we have to give the parameter reverse, and we have to assign the value true. So once we do this, now when we execute this, you can see we have the return as the same list but in the opposite order. So that's how the reverse parameter works. Now let's try to understand how we use the key function or the key parameter in the sorted function. Now, of course, if we want to sort something based on some key that we want to define, we use the key parameter. So let's take an example now. So in this example, what we have done is I've defined this function called take second. So what this does is it simply takes the second element of a list of tuples. So what is this list of tuples? Well, this is random. You can see this random. This is a list of tuples. So this is one tuple, this is the next tuple. And what I'm going to do is, in this example, I'm going to create a key out of every second element in each tuple. So I'm going to create a key out of 20, 40, 10, and 13. And based on these, in an ascending order, I will sort this whole list. So what my result should be is that since the smallest of the every second object in these tuples is 10, so this will be my first object in my sorted list. Then it should be the one with 13, because this is the next highest number. So then this will be the next object. Similarly, this will be the next object, then this will be the whole next object. So you see, I'm using every second element of the tuple as my key. And for that, to create a key, basically, I'm creating this function, which will basically return every, it'll iterate through all of these and it will return each of these second elements. So let's actually do this now. So what I have here is, I am going to create a sorted list, which is going to use a sorted function on this iterable, which is a bunch, which is a list of tuples. It's called random. Now my key is going to be take second. So this sorted function is actually very dynamic in the sense, I don't exactly have to create a list directly, each of these objects present in the tuples. I just have to define I can even pass a function in the parameter for key, and it will apply this function on the iterable that we pass over here, which is random namely, and it will use this function to generate keys, generate a key out of each second element, and based on that it will do the sorted, it will perform the sorted function. So now if I check what's my sorted list, you will see that, as I had mentioned, now it's using the second objects, or the second each second object of the tuple as the key. So since 10 is the smallest, this whole object is the first object. Then 13, so we have this object here, and then so on and so forth. So this is how we've used a key to do the sorting function, a key that we've defined on our own. Now similarly, we can use multiple keys as well. So just to quickly go over through this, we have this some list where a bunch of names, a bunch of tuples, you can see, right? Tuples with 3 objects each within it. Each first one is always a string denoting someone's name, some student's name. The second is the marks out of 100, and the third is their age. So what we have here is, what we want to do is, we want to sort these tuples in the order of first marks, and in case the marks are clashing or they are the same, basically, we will sort by the age. So what we want to do is, we want to first sort by these marks, as you can see here, but in case they clash, for example, like say this 75 and 75, they're the same marks. In that case, we want to sort it by the age, which is 12 and 20, which is different. So in this case, we're going to use 2 keys. One for the first key will be given the highest priority, and then if there is a clash, then we use the second key. So how do we do this? Now let's define some function, like how we define this take second function here. This will be our function that we will pass to the key. This function basically what it does is it gives us who has the highest marks. Now since we are creating an since the key works in an ascending order, so the smallest object in a key is the first object that gets returned, right? So what we're going to do is we're going to return the error, which is basically the difference between 100, which is the total marks, and the marks the student gets. So this is how we obtain a ascending order in our list, which is what we, which basically is what we want, because we want the highest marks to be first. So we do 100 minus item 1. Item 1 is basically the first object of whatever iterable we pass. In this case, it would be the first objects of each tuple, which is the marks. Secondly, we want age. Age is the item 2, which is each second object of each tuple. Now, what we return in this function is like this is going to be our key now. A list of errors and the list of age. Error being the marks error, the difference between 100 and the marks you obtain. So now what it's going to do is it's going to take the marks as the first key and the age as the second key when we pass this to a sorting function. So if you skip this, you don't have to look at this, but if you look at this now, we have the sorted list, which is going to be the result of the sorted function on top of what we pass, which is the participant list. Now we're going to use the key. We're going to use the key as the sorter function. So we're going to use the sorter function as the key. And when we print, if you see, we get, let me just execute all of this. So if you see here in this section, what you can see is we have the highest marks first, then the second, then the third. But if you see here, there's a clash. This guy and this guy have the same mark, 75. So now what we want to do is the guy who has the younger age should be in the first in the object. So that is how this has happened, because we've passed two keys, error and the age. So when the clash in error key happened, we went to the age key and then we did ascending order on that. And then finally the rest of the objects that you can see here. So now that we've seen how the sorted function works, now let's look at how the lambda function works using this sorted function, which was the main goal of this video, right? So let's see. So now some of you might have figured out where this lambda function will be used, right? So whenever we were using the key in the sorted function, we had to define a function and then we would pass that function as the key. So as some of you may have figured this out, what we're going to do using the lambda function is we're going to skip that process of defining a function with a new name and all that, and we're going to pass a lambda function, or we're going to use a lambda function as the key. So let's see how we do it. So initially what we've done is we've created this list. This list is a list of dictionaries that you can see. So this first object is a dictionary, second object is a dictionary. Each dictionary contains two keys, the name and the age. And the values are something like Nandini, the values for age is like 20, 20 and 19. So we have three dictionaries in a list. So what we're going to do is we want to print what we want to do with this. We want to print these objects or these dictionaries in an ascending order of age. So obviously we want this to be first and then this and this, because 19 is smaller than 20. So let's see how we do this. So if you go here, what we're going to do is we're going to print the sorted function, or the result of the sorted function being applied on this list. So this is our iterable. Now if you see here in the key parameter, we don't predefine a function and pass it over here. Instead we use the lambda, and this lambda function is defined in such a way. So we say lambda, it will take one argument I, and then it will return basically the age index for some I, and this I is, we're going to presume an I to be some sort of an iterable which has an index called age, and which is the case in our case, right? We have a bunch of dictionaries where there is a key in each of these dictionaries called age. So we're going to use that. And now you're going to ask, like, what is I? Well, when we use the lambda function in the sorted function, this I will basically be each object that we get when we iterate upon this list. So we're going to iterate first on this. So it's going to take this dictionary and it's going to search for the age. Then it's going to take this, it's going to search for the age. Then it's going to take this and it's going to search for the age. And each of the time it will pull out what is the value for each of these age keywords or these age indexes or age keys. And out of these objects, so 20, 20 and 19, or these values, we're going to create a key with which we're going to sort each object in this whole list. Okay, so this is how the lambda function will work here. So let's do it. So as you can see, our sorted list now contains this object first, because 19 is the smallest age, and then this and this. Now you might see that there are two 20s. So how do we control which one comes first? Well, by default, it will just give us the result in the way we passed it in the original list. So since Nandini came before Manjeet, in the result also Nandini will come before Manjeet. But what if we wanted to sort it even more? What if we want to sort it in such a way that first we go by age, and the second key will tell us that if there is a clash in ages, we have to go alphabetically by the name. So in this case, we will create a second key. And how we do that? Well, if you go to this step, over here what we're doing is, we're doing the same sorted function, but now the lambda will again take one parameter, which is I, which is going to be each object in this iterable list, and we're going to take two keys. So the first key will be the age key, and the second key will be the name. So it will first sort on age and then on name. So now if you see, the result should be that Manjeet will come before Nandini, even though the ages are 20, because M comes before N in the alphabet. As you can see, this is the result. Now if we wanted to do the same thing, but in a descending order, all we have to do is, after this key parameter, we have to give another parameter called reverse, and we have to give it true. So if we did this, now you see this, or if we do it on this one to be more clear. Now if I execute this, basically this whole whatever result we get will be backwards now. Oh wait, I did not enter it in the sorted function. So this should come within the sorted function over here. So now if we execute this, you will see Nandini comes first, Manjeet comes second, and then Nikhil comes third, because we've done the reverse. We use the reverse keyword as true, reverse parameter as true. So this was a brief lesson on lambda functions. I hope you understood or appreciated the way we use lambda functions in Python and the situations that we use it in.
And with that, we have come to the end of this tutorial. If you guys feel that we have missed out on some important topics that we were supposed to cover in this tutorial, then please feel free to drop them down in the comment section below, and we'll have your questions answered. If you guys liked this video, then do give it a thumbs up. Please comment your doubts below, share it with your friends, and don't forget to subscribe Simplicode. Thank you.